Okey, mic ada. Mic satu ada. Okey.
Yang ni tak payah cari TikTok lah.
Dia kan office dia?
In case down, yang ni kena pakai ni. Slide tadi kau ada kan? Kau share nanti. Dr. just sebut ni ni je.
Dr. Azmi je.
Boleh?
Tak payah cerita katak buat terpurau Psn tahun depan. Tak payah. Hari ni pakai baju putih nampak lah. Tak kemarin nampak gigi je. Okey, suara ada, gambar ada. So sekarang ni nak kena buka yang ini. Okey. Buka WhatsApp. Okey. Harap ada suara. Macam biasa aku akan tanya direct
Host.
Kau mesti kan?
Aku host.
Tak, kau pakai name siapa tu mesti?
Mesti lah. Mesti satu kau.
Tak, setiap sini.
Mana?
Ni. Lepas dia pakai wifi, so yang ni tak tutup. In case down terus tukar. Apa dia?
Aku tak masuk lagi. Ada tapi tak masuk lagi sebab tak jumpa email lagi. Tak jumpa email. Kan dah humming tu, kan dah echo tu.
Dah kau dia kopi ke? Kopi.
Ini tak sama gitu.
Ya, sudah macam tenang je.
Ini dah sambung.
Tak ada.
Oh, dia silap. Dia pergi jemput tempat lain lah. Dia jemput kat akaun lain.
Tak, kalau tak ada, masuk je akaun saya.
Tak apa. Kena buka akaun lain.
Resend balik, resend balik.
Dia masuk, dia bagi kat akaun
Resend balik. Resend. PTPM. PTPM bro. Ada.
Tak buka kan.
Saya dah resend baru. Atas. Atas ke? Jangan.
Oh, silap. Modul E Alright, masuk.
Last meeting.
Kita share dekat
Share macam ni.
dekat sini, dekat dalam sini.
Aisyah,
tu sound tu.
tak, saya tengah nak sambung ni.
Tak ini dia tu.
Fik.
Dia ni tutup. Ni tu.
Fik.
Jap.
Aku tak boleh on mic. Aku on mic dia echo. Right. Handphone
Kenapa ni broadcast untuk ni je, untuk attendance je dulu.
Dekat telefon tak payah on. Bluetooth off. On dekat sini.
Dah 851 weh. Participant tak nak login.
Aku start webinar.
Ini pukul 9 baru start Prazmi tau.
Tahu.
Jadi attendance je dulu.
QR code.
Sebab tadi doktor on dekat phone so dia tak boleh nak tarik dulu. Dia kena off sini, on sini. Kalau off sini boleh, baru boleh tarik. So nak file.
Tak baca juga.
Tak payah baca ni Dr. Azmi.
Masuk dalam file.
Vic, aku pakai spy attendant.
Apa dia? Tak boleh lah.
Aku share my attendant, Vic.
Jangan punya mic.
Dia nak share smart attendance. Biar bagi dia share. Dah memang dia share sekarang. Session start ni saya buka mas tu.
Cuba cakap siapa ada mic on balik. Pagi dah on dah.
Off.
Hello.
Saya punya mic.
Kena ada headset. Notebook off mic ni
Tapi dia dah masuk dekat ni. Dah terdengar. Dah terdengar. Yes.
Aku start webinar.
Ada speaker tengah on bilik ni.
Test 1 2 Pro.
Okay, aku try balik. Aku dah tolak ke headset.
Test mic.
Test 1 2 3. Okey ha. Dia nak start tak?
On Dr. Fitri okey tak? Mic dia tu. Bergema tadi.
Dah settle dah.
Tadi sebab ni apa Prazmi.
Aku cucuk headset. Tapi keluar dekat speaker.
Oh ya ke? So settle lah.
Saya
Dr. Fitri okey, Dr. Fitri. Nanti tu.
Tak boleh.
Fitri.
Tu bukan aku.
Gema lah.
Tu grafik.
Okey tak? Tak bawa. Tak apa, aku slowkan speaker je, tak ada show.
Dr. Fitri, test.
Tak, kau nak pakai ni.
Test.
Bluetooth.
Okay, clear. Video mana Dr. Fitri?
Dia senyum.
Video.
Okey. Kejap, kelas apa ni?
Kepai dulu.
Background ke? Virtual background tak ada? Dr. Fitri.
Pair dulu. Ha?
Virtual background, Dr. Fitri. MPP punya background. Dr. Fitri.
Aku tak payah pakai MPP. Aku PowerPoint.
Dr. Fitri.
Dia tengah ni. Sekejap
Okay.
Tak sangka.
Okey.
Afiq.
Share tu.
Attendant dulu.
Nanti bila dah share, kita dah baca. Bila doktor cakap okey, saya kenalkan pesara kepada Fendi. Sorry.
Jauh lagi tu.
Sorry. Waldi, pasal apa akan naik.
Mic on tu.
Speak, saya baik dengan slide. Waldi, naik dulu. Ni, ada intro. In case down, wifi tutup, terus alih di sini. Jadi saya pun saya dah on. Kat sini, saya dah on. Tinggal on video dengan
Dengar suara Syam je.
on video dengan
Kasih chance lah dia masuk suara. Asyik orang lain yang masuk suara.
Suara lah.
Broadcast lah.
Broadcast lah sekarang.
Dah.
Recording in progress.
Macam mana saya nak option tu ni?
Bone conduction. Ya. Ya. Mana apa?
You call tadi.
I call ni. Tak, aku rasa, sorry, rasa si Afiq dah pakai Bluetooth, so dia end up calling you. Okay. Alright, okay, bye.
Bye.
Aku unpair. Okay, dah jadi senang Sorry. Panik aku sekejap bini aku call. 29. Berapa? I tak share. Ni spotlight kot. Syap, Afiq. Kau spotlight aku Aku tak sharing.
Boleh start. Start nak tulis tak?
Okay. Assalamualaikum dan salam sejahtera. Welcome to the 23rd Medical and Health Research Week. Our today's module is Statistics in Research 2. Before we start, allow me to give a brief introductions of our one and only speaker, Associate Professor Dr. Azmi Muhammad Tamil. Associate Professor Dr. Azmi Muhammad Tamil is a 54 years old UKM lecturer who will be retired next year. This is his last research week session before retirement. As a student in UKM, he was a nuisance to his JKM lecturers for disputing the statistical formulas taught. Later, he ended up dreading the same things happening back to him. Graduated from UKM in 1992, and he taught statistics in UKM since 1996. He is the ultimate example of a frog under the coconut shell, since he never left UKM. More well known on the internet as a technology enthusiast rather than as an epidemiologist or biostatistician. He has many blogs on all his interests such as gadgets, hacks, triathlon, cycling, and statistic blogs such as drtamil.me. He also has a YouTube channel on statistics and cyclings. So without further ado, please welcome Associate Professor Dr. Azmi Muhammad Tamil.
Thank you, Dr. Fitri. My apologies. I am looking at the wrong screen right now. Okay. Asyik mouse tak jumpa. Okay, thank you very much, Mr. Chairperson, Dr. Fitri. Okay, I will start this session with introduction. Okay, I'm going to share the slide. Okay, my apologies. Okay, the first thing first, I'm going to share a slide. This one was the question that was asked the last week on Friday. Because this one is going to cover what we cover today also. Okay, I'm going to share screen now. So I'm going to share screen 2. Click share. So hopefully this thing become sharper and clearer. Okay. So the example given was basically about when to use chi-square, when to use t-test, and so forth. Okay. So I'm going to cover this. Okay, I'm going to cover this. Just the basic part. Okay. So for example, we take example, you are in your study, you're measuring the BMI, the body mass index. And as you all know, the BMI, body mass index, is a continuous data. Therefore, if you are trying to compare, okay, the BMI between male and female, Therefore, you have to use the student t-test to compare. Okay, I need to take out the mask. It's affecting my presentation. My apologies. Okay. So, because you are comparing the mean, therefore, you use the student t-test. Compare mean, student t-test. But if the BMI is recategorized to become normal and overweight, then you are comparing whether there's a difference of normal and overweight between male and female. Then you use the chi-square test. Okay, chi-square test. Okay. 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 So to summarize, okay. So if you're having the continuous data and the continuous data is in terms of you're comparing between male and female, and so when you're comparing male and female, you're comparing the mean and standard deviation of the BMI among the males and versus the BMI of the females in terms of mean plus minus standard deviation. You will use student t-test. But if you are using it using the recategorized data, which is the BMI has been recategorized to become normal weight and overweight, then you will be using the chi-square test. So that's why I want to emphasize. Okay, if you are having the data is continuous data, you use student t-test. If the data is categorical data, normal weight and overweight, you will use the chi-square test. So that is how we will start today, so that you understand the difference between the lecture from last week on Friday, which is about the chi-square test, and today we're going to cover about the t-test. Okay. Okay, so today we are going to cover the second most common analysis that you use during statistical test for your research paper, for your thesis, which is you're going to use the t-test. You're going to use the t-test. All right. Okay, there are many kind of t-tests. Okay, there are many kind of t-tests. You are going to hear single t-test, independent t-test, student t-test, paired t-test. So when you student t-test is independent t-test. They are one and the same. Paired t-test is before and after, where you compare the value before and after the intervention. Then you have Anova, when you have to compare between many groups. When you have to compare the mean between many groups. Okay. All right. So who started this test? The test was started by a person by the name of William C. Gosset. Okay. And why they did not call the test as Gosset's test? Because at that time, William C. Gosset was working with Guinness Breweries. I'm not sure whether you know about this, but Guinness Breweries used to be popular for this advertisement. Guinness Stout, anggal lagi, nalade. Guinness Stout is good for you. Alright, so one of the things about these companies, they are worried about their trademark. They're worried about their trade secret. So the trade secret is how they produce the fantastic beer. Yeah, of course, I don't know whether it's fantastic or not lah. Despite my name, Azmi Muhammad Tamil, nama saja Tamil. Saya anak Tamil tapi orang Melayu. Okay, so uh, to protect their trade secret, their staff are not allowed to publish anything, okay, to avoid their secrets from being leaked. But of course, William C. Gosset, he's a statistician. He does not know about the chemistry part of making beer. But he still was not allowed to publish. Therefore, he had to publish using a pseudonym. So the pseudonym that he used to publish his paper on students' t-test, okay, he used the pseudonym of student. Because he used the pseudonym of student, therefore, the test become known as students' t-test. Okay, the test become known as students' t-test. Okay, so that is the history of why this thing was called a student's t-test. Okay. I'm still not getting the screen that I want, but never mind, we just proceed. I'm supposed to see the big screen, but it's showing me a different screen right now. Okay, I'm going to go next slide. That's a problem when you have so many screens. That's a problem when you have so many screens. Okay. So what happens in a student's t-test, as mentioned earlier, when you are comparing a student's t-test, you're comparing the mean of two groups. You're comparing the mean of two groups. For example, you have a group of pregnant mothers. These pregnant mothers uh, were started with being anemic or not enough blood at the early part of pregnancy. So you have a intervention. What is the intervention? The treatment group was given injection of iron. Okay. The control group was given iron tablets to take orally. Okay. So after 3 months, you compare the mean hemoglobin level between the case and control. Okay. So therefore, this kind of test, you're going to use the test, a student's t-test. Okay. So why? Because there are two variables involved here. One is the hemoglobin level, and the other one is the grouping, the treatment group and the control group. Okay, so that is, as you can see in the formula, it is the t-test is done by comparing the mean of the first group against the mean of the second group. Okay, so some more examples are given here. Okay, another one is comparing the level of blood cholesterol between hypertensive and non-hypertensive patient. And of course, the other one is comparing the HAM-D score of two groups of psychiatric patients treated with two different types of drugs, which is fluoxetine and sertraline. All right. Okay. Any problem? No. I'm not coming out. Apa dia? YouTube kacau. Okay, so they're saying that my YouTube is not coming out, so I'm not worried. Oh, I'm sharing the wrong screen. Okay, thank you. I'm supposed to be sharing the big screen. Thank you. Okay, hopefully I'm getting the right screen. Okay, 1,000 apologies. There's a problem when you have so many screens. You do not know what screen you're looking at. So right now I'm trying to get the correct screen to come out and the wrong screen came out. Okay, no wonder I cannot see the... Okay, my apologies. Thank you very much for Afiq for pointing out that I'm sharing the wrong screen. Okay. Okay, so you're trying to compare between two groups. Therefore, that is the test you use, which is student t-test. Okay, the chat. Okay. Okay, now I'm not going to touch the chat yet. Not yet. Hopefully, the other host and admin can handle the chat. Okay. So when you're trying to compare the mean, if you're comparing the mean, so this one is example of how you compare the mean between two groups. So here the example given is the two drugs, fluoxetine and sertraline, comparing the level on the anxiety score, the Hamilton anxiety score on week 6. So you can see that after 6 weeks on fluoxetine and sertraline, the patient are very, very happy. They are no longer having anxiety attacks. The score is almost the lowest possible, which is 4.25 and 3.8. Therefore, there is no difference in terms of the effectiveness of Zoloft and Prozac in treating the anxiety of this patient. So you can see here, the t-test showed that the p-value is not significant. So right now we're having the speaker coming out on the other side. All right. Okay, so that is the concept of t-test. Okay. So among the things that, as mentioned last Friday, for you to do a student t-test, the data must be normally distributed, the population variances are equal, and the two groups must be independent of each other. So if you are comparing two groups, then you're okay. Example, you're comparing male and female. There are two groups, they are independent of each other. You cannot be members of both groups. Okay. So t-test is like that. You must be independent of each other. So these are the formulas for t-test. Again, as I said before, these formulas are just for you to understand that there is such a formula exists. But for your thesis, please don't do manual calculation. Why you're not going to do manual calculation? Because you don't want to. We don't want you to waste time. We don't want you to waste time running the analysis manually, because the computer can do it for you faster. Okay. What software you can use? You can use SPSS. The notes are there on my website on how to use SPSS. You can also use Studio R. Studio R. Also, the notes are available on my website. Okay. So we are shifting away from SPSS because SPSS is very expensive. Studio R is free. Studio R is free. So these are two formulas that you can use to calculate the t-test. So this is the most commonly used formula, which is for samples larger than 30, and this one is for the smaller sample size, where you need to combine the, 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 the variance. Okay. All right. Okay. So what is the aim? The aim here, what you are trying to see is if the t-test, if the test is significant, it means that one group has improved better than the other. One group has improved better than the other. So usually, because in our study, we want that the treatment group to be better than the control group. So the better the improvement, the larger is the mean difference between the two groups. The larger the mean difference, the more smaller is the p-value, and the more smaller p-value, the more significant is the p-value. As you mentioned earlier, the p-value is indicative. The chance of this difference being due to random chance rather than real difference. Peluang di mana perbezaan yang dikesan adalah berlaku secara kebetulan, bukan perbezaan sebenar. That is the meaning of the p-value. So you want the probability that this is in error as small as possible. Okay, the bigger the mean difference, the bigger is the t-value. Therefore, the smaller is the p-value. Therefore, more likely to be significant. The smaller the variance, the smaller is the p-value. Okay, so please take note of that. So there are two things. You're looking at the difference of the mean, and you're also looking at the standard deviation. The square of standard deviation, you end up with variance, and the smaller is the variance, you end up with a larger t-value. The larger t-value, the smaller is the p-value. Okay, here's some example that I've shown you. Okay, basically what I'm trying to show you that if you calculate manually, you need the mean and standard deviation. By knowing the mean and standard deviation, you can calculate the t, and once you get the t value, okay, once you get the t value, you can get the p value. So this is the t value when you're doing calculation manually. Okay, I'm not going to worry about this. I know you cannot see some part of the slides. Okay, but don't worry, it is not important because you're going to do everything by SPSS, okay, or by using Studio R. So this is how we get the p-value if you're doing the calculation manually. So since the p-value is smaller than 0.05, okay, the p-value, so the chance of the error happening by chance is less than 0.05, less than 5%. There is a significant difference of the cholesterol level between the hypertensive and normal patient. And hypertensive patients have a significantly higher cholesterol level compared to normotensive patients. All right, so that is the how we do a student t-test. So this one is the example we tend to do in my class. I'm not going to do it here, but the whole point here is just show that there's a difference of marks of 11.255. Okay, we can see that the mean difference is 58 and 47. Standard deviation is 14. Is there a difference? Yes, it is different, and it was significant. Okay, so I'm not going to worry about that. Let's go next one. Okay, so you can see here the difference is significant. There's a difference of marks with the two groups of students, and it is very small p-value, 0.00000003. Okay, that is an example of how we do a student t-test. Okay, inside the notes, I also give you on how to do it using SPSS. Okay, the data is available for you to download. As mentioned earlier, all this data set is available either from drtamil.me. You go to drtamil.me, you search for SPSS, you'll get the notes on how to analyze using SPSS. Or even easier, since you all are already on Open Learning. Okay, semua orang dah ada kat Open Learning kecuali 14. Ada 14 orang je yang tinggal yang tak ada kat Open Learning. Okay, so you can go to the Open Learning where I have the notes for you. Remember, tinyurl.com/fk6163stats. You go there, you can get the notes, you can get the PowerPoint, you can get the video on how to do the analysis using SPSS. Okay, no need to pay anything. Last time we used to charge to have the bengkel, but we're not going to do that here. You're not going to have to pay for the bengkel. Especially we give to you the notes for free, the video for free, the exercise, everything for free. Okay, gratis. What do I want? I just want your doa and prayers that I live a good, healthy life. Okay, how much I hope for a good, healthy life? Every day I cycle 10-20 kilometers, hoping to get my weight down because I already had a heart attack in 2018. So before my next follow-up in December, I better get my weight down some more. Hopefully my glucose level down and my BP down, so that the doctor is happy with my progress. All right? Okay, please pray for me. Okay, so how to decide for the t-test mentioned just now? You just look at the 11 test, decide whether the variance are equal or not. You just look, both are given up and down, you just choose one of them. So if the variance are equal, you use the top one. If the variance are not equal, use the bottom one. Everything is covered inside the notes. I'm not going to cover it here. How you present the result, it should look something like this. Okay, just something like this, where you have the mean of the two groups, and then you have the t-value, then you have the p-value. Okay, the only thing you have to remember, Gaya UKM, they only have the roof, they have the ceiling, they have the floor. There is no tiang. Take out all the pillars for Gaya UKM. Okay. Right. Okay. So if we finish the first part, there are two more parts, so I cannot delay this any further. So the other thing is, if you're doing between two different groups, you use students t-test. But if you are measuring the same group again and again, okay, for example, as mentioned earlier, okay, HUCAM is full of obese people. Okay, here only Fitri is not obese. Dia outlier. Don't worry. We wait for him 10 years, 20 years from here. He'll be same size like me or Lukman. Okay, so that is the effect of working in academia, where you are always sitting on the chair. Okay, so if you have a group of obese people and you want them to lose weight, so what you do, you get them enrolled into a weight loss program. Okay, for example, you have a biggest loser contest, you compare before and after. Okay, so basically you're going to measure the weight before and measure the weight after. So it is a repeated measurement on the same individual. Okay, so if there is a difference of weight before and after, therefore the difference should be larger than 0. Okay, example. Okay, let's say Dr. Dr. Hamad started a program of weight loss among his heart patient. Okay, Dr. Hamad started a program of weight loss among his patient. So if there is a difference of weight before and after, therefore if the weight before minus the weight after, the difference should be larger than 0. If you have the difference is after minus before, the value should be in the negative. If the value is the same as 0, means there is no difference. The program has failed. Okay, so that's why we have the value 0 there. Just to show that if there is no difference before and after, then the value will be close to 0. The difference is close to 0. Otherwise, it does not make sense. Why should you minus 0? Because the 0 there is just to remind you that if there is no difference before and after, then the value will be close to 0. If there is difference, it should be larger or smaller than 0. And this is the formula. Again, I will tell you, do not worry about the formula. Just take note that how it is derived. The formula is derived based on the difference and the standard deviation and n, the number. Okay. So that day we had a discussion about sample size. How do they derive the formula for the sample size? Because of this. Okay. Because of this. You reverse back the formula, then you get the n for the sample size. Okay. So D is the difference. Okay. So that's why when you calculate the sample size, we want to know the expected difference and we want to know the expected standard deviation. The t we will set at 1.96. Okay, the t we will set at 9.96. Then we can get the sample size. Remember inside the formula, the 1.96. So when you calculate sample size, in fact, it is just the t formula being inverted. Okay. So that's why all these lectures are related to one another. The sample size lecture and the t-test lecture is all very much related. So you use the formula to calculate the t value. So from the t value, okay, you will get the p value. Okay. Some examples of PET t-test. Okay. We have the patient treated with sertraline or Zoloft. Okay. They are treated between week 0 and week 6. Okay. When they come in at week 0, they are very depressed. They are very suicidal. They want to commit suicide. Okay. Nowadays, there's a lot of videos going on WhatsApp and Facebook of people committing suicide. I don't know why people like to share it. That day, somebody sent a video saying that somebody in my apartment committed suicide in Subang. I think I had a look at the video. I said, Subang don't have this very high cliffs. This is not in Subang. I searched for the video. Turned out the video was from China. Okay, so don't believe whatever that is being forwarded online. Cuma tipu saja. Okay. Okay, so if there's a difference between week 0 and week 6, okay, then the score should be better after 6 weeks of treatment with Zoloft or sertraline. The one that we always use in JKM and in ONG, we like to compare the hemoglobin level among anemic patient, okay, amongst anemic pregnant women after treated with 6 weeks with Martinix. After 6 weeks with Martinix, we are hoping the patient to have improved HB, but usually that never happens. Why? Because the iron pill tastes horrible. Okay. That day I complained my wife why she's not taking the iron pills. She asked me to swallow the iron pill. I vomited. Tastes horrible, man. It looks like pieces of stool, brown in color, that size, that big. So after that, I buy for my wife Obimin. So after that, she took Obimin, no problem lah. Okay. Okay, so here's some example of calculation done using Spss. So you can see clearly here the anxiety score after 6 weeks of treatment, it is much better and the p-value is significant. How do we know it's better? So the score at the start of the week 0, the score is 13. The score of the anxiety score after 6 weeks of treatment is 3.8. So there's a big difference there. and the p-value is significant. How do we know it's significant? The t is larger than 1.96. You can see here it is 8.5. So therefore it is very much significant. Okay, so that is how we do the PET test using Spss. If you are doing it manually, it is a horrible thing to do. Why horrible? You're going to waste the time of your life for nothing. Better go and do locum. Okay, so you can see here, here's an example of the BP before and after. Okay, this is a BP of patient coming in to sit down in the clinic. After they sit down, they rested for about 10 minutes. We measure the BP again, and then we see whether the BP is lower or higher. Okay, this one, clinic cardio should take note of that. Clinic cardio, not only there is not enough places to sit, we are standing outside the measurement room. After we are standing for so long, waiting for our turn to be checked the BP, then they come ask us to sit down and they immediately measure the BP. Of course, the BP will be high. Okay, but of course I'm a bit cleverer lah. Kita sudah belajar statistik kan. So I make sure before I go and measure my BP, I sit down quietly. Then when they call my number, I walk in slowly, very calmly, sit down, take a deep breath before I allow them to take my BP. So until now, they have never increased my medication. In fact, they have reduced my medication because every time they measure my BP is always very, very low. Okay, so remember that. You want to have a low BP? Relax. Don't be stressed out. Today, right now, you check my BP is above 150. I know already, I checked. Okay, why? Teaching you all very stressful. So this one is the measurement manually. As you can see, it is very, very complicated and very hard to do. So don't do it manually. Use the Spss. Okay, this is a very masochistic exercise. If you're into pain, then go ahead and do this. Okay, but the whole point here right now, what is important is look at the p-value. You can see the p-value is less than 0.05. Therefore, the null hypothesis is rejected. Yes, there is significant difference of systolic blood pressure between the first and second measurement. Okay, the mean average of the first reading is significantly higher by 3.11 millimeter isogrum compared to the second reading. So, guys, those who are having high BP, like myself, please take note of that. Have good rest before you measure your BP in the clinic. Okay. Again, I'm very generous. I give the notes on how to do this manually. Okay, not only you have the slides on how to do the test manually, we also have the video and the PowerPoint available from the website and from the Open Learning website. Okay, so the whole point here is just how to, and here I show you also how to present the result inside the t-test. Okay, sorry for rushing, but we're already 9:35. I'm going to have only 5 more minutes. You mean then? Okay, so next one is the Anova. Okay, Anova is the word for analysis of variance. It is an extension of the student's t-test. It's sambungan. Although the name is nice, Anova sounds like a good name for a girl, but don't give your girl this name. Okay, so don't be fooled by the name. Anova does not compare variances. It just compare the mean between more than 2 groups. Okay, so you test the equality of two or more population mean. So example, you're trying to compare the height between the height of Melayu, China, India. But the most common thing that we tend to do is the blood cholesterol level between Melayu, China, and India. For your information, Indian won, followed by the Malay, last is Chinese. Okay. So we did the study way back in 1992 between bus driver, bus conductor, and taxi driver. Okay, who got the highest cholesterol level? Taxi driver, followed by the bus driver, and the lowest is always the bus conductors. Okay. So you have 3 groups. So you do Anova. Again, you need to be normally distributed, and they should have equal variances. And the members must be independent of each other. So here's some examples of the analysis. Okay. I cannot get out from the screen. By right, the camera should be tracking me this side, but it's tracking me to the right side. Okay. Tak boleh. Okay, never mind. Don't worry about that. Okay, so this is how we do it. Next. Okay, so again, there's manual calculation for Anova, but I'm not going to show it because it is very, 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 very complicated. Okay, you have to calculate many, many times. So here's the formula for the manual calculation. They got the SSB, sum of squares between groups. Okay, then they have the, this is how we calculate the sum of squares between groups, which is a lot and complicated. So I'm not going to go into detail about that. Then we have the MSE, the mean square error, something like standard deviation. Okay, so you look at the MSE, mean square error, which is the difference of the mean square error is a measure of the variability of the variability after the group effects have been taken into account. So they're going to measure the difference of everything here, of every single item here. Okay, this is the formula for the MSE. Okay, as you can see, it is complicated, and you have to get the difference for every single observed data, which is very, very complicated. So you're going to have to sum up all the differences here like this, then put all the differences into the formula, and then you get the what we call the MSE. So from the MSE, you will combine the MSE and the SSB to get the what we call the F value. So we have to get the F value. And the F value, this is how we formula for the F value. And this F value is converted from the F to become the P value. So this is the table for the F distribution. Okay. So here you have an F value of 89.015. So the largest we have here on the graph is 4. And we need to look for F. Not possible. So therefore, you end up with the value which is significant. Okay. And that is how we get the Anova. Okay. And Anova is presented like this, where we have the SSB, the sum of squares between groups. We have the MSE, the mean square error, and we have the F value, and we have the P value. Okay. Okay, so I already give you the answers, so I'm not going to do one by one. Okay, these are all the answers. Okay, and with that, I think I'm done. Hello. Okay, we're done. Okay. Okay, I'm going to change back my screen and going to go. I hand over the session back to Fitri, the chairperson. All yours, Fitri.
Okay, thank you. So I think we only have like one question, but this question was posted before you explain about the PET test. But give a brief description about the difference between PET test. Thank you.
Okay, I'm very sorry if because what happened just now, I did not mute my mic. So maybe you want to read that again? I mute my mic first.
Okay, we have one question. The question is, what is the difference between student t-test and PET t-test?
Okay. Okay, thank you very much. Okay, very sorry about that. There's a problem when you have two devices inside the same room. When you have two devices inside the same room, if the both mics are on, under Zoom, they will automatically nullify the echo, but they end up nullifying the sound of the speaker. So as mentioned just now, we already mentioned student t-test, you're comparing between two groups. Okay, and when for the PET t-test, when you're comparing before and after. All right. So we got another one here from Chin Jian Wei. Okay. The difference in maxima and PET t-test. PET t-test continuous data, maxima for categorical data. Okay. So I repeat again. PET t-test is for continuous data. Maxima is for categorical data. All right. Okay. Thank you. Okay.
Okay. So I guess we don't have any more questions. But if you do have, please just post in the Q&A or chat sessions. So we will go back to that later. So, Prof, we have another 3 minutes before the next sessions.
Okay. Minum air sekejap.
Okay. So we take a break for 3 minutes. Okay.
Huh? Vibrate. That's the whole point. Dia do bone conduction. Tak ada, aku tolak ke sini. Dia kena kat tulang depan ni. Kena tulang tak apa. Geli. Macam ada penggosok. Tak, memang saya tahu ada.
Oh, ada.
Saya yang buat kata kerja minta benda ni. That's why you can see the effect. So you can integrate the slides and together. Okay, I can cari slide balik. Cari slide. Okay. Lepas ni apa? Correlation
Correlation and regression.
Tak nak? Tak off? Tak, but that's how it works lah. It's based on okay, kena tarik screen. Tarik screen. Yep.
Nanti ada multiplication mix Anova and Manova. Kau tak ada jawab.
Itu kena cakap. Nanti bagi link.
Okay. So should I ask you later lah?
We just start kan, I just bagi cakap.
Okay.
Okay, kejap
Start
Okay.
Okay, Assalamualaikum dan salam sejahtera. Welcome back. So before we start with our next sessions, with our next lecture entitled Correlations and Linear Regressions, we do have one questions. Hi, so the question is, can you give a brief description about mix Manova, Prof?
Okay, thank you very much, JC. Okay, now my mic is on. Alright, okay. Okay, the good news for JC Link, the notes are available online. You just go to drtamil.me. You click on FK6193. There's a button on the top right side. Nanti you see FK6193. That one will show you how to do all these different types of Manova. Manova is a multiple Anova. Okay, multiple Anova. And basically, it is really a form of what we call GLM, General Linear Model. Okay, it's not that I don't want to teach you all here, but Manova is a 3-day session just to cover about it. So we are going to basically you just go to drtamil.me. You click on FK6193. You will see a long list of advanced topics that we're not going to cover here. Okay, have we covered this before in research week? Yes. I tell you, not only the student slept, the lecturer also slept. Okay, so it is such a dry and boring topic. We don't no longer cover this during the research week. Instead, it is only for special workshop. We conduct this special workshop. We call it advanced workshop, and you can join them. For those who wanted to have the video of all these lectures, you go to my YouTube link, which is youtube.com/drtamil. /GRTamil. You just Google for GLM, GLM, General Linear Model. Everything we cover there. From univariate, multivariate, repeated measures, everything we cover in detail, step by step. Each one of them is 8 hours. Each one of them is 8 hours of session. Okay. All right. And with that, I'm going to go back to the topic at hand. The topic at hand today is correlation. I'm not going to cover all. I think I'm just going to cover basic correlation and linear regression because I don't think I can cover everything. Okay, let's see. Okay, thank you, Faris. It's drtamel.me. We already informed this on Friday. Remember my name? Tamel. So drtamel.me. Me who? Me. I'm paying money, every year for that domain name. Okay. Rasa bodoh lah register tu, tapi I found out students can remember that easier. Somehow my father's name is a blessing in disguise lah. Okay. Although I grew up fighting a lot, I still remember the call names. Mi masak lemak, mi kahwin dengan mamak, boom, bertumbuk kan. So I grew up fighting. I really grew up fighting because of the nickname. Okay, but nowadays people remember my father's name easier than my name. By the way, my siblings also have the same horrible experience. Even worse, my father gave the name A, B, C, D, E, F. Azmi, Baria, Haril, Dazman, Imran, Farah. So people know who we are and what is our giliran. Okay, so let's go back to the lecture at hand. So the lecture at hand is this. Okay, I think I have not shared screen. Okay, now I'm sharing screen. Okay, again, when I share the screen, everything goes missing. Okay. Okay, that's why suddenly I become very quiet. Because now I have to shift all the screen around. Okay, so now we are back online. Okay. Okay. This is my glory days. It was the year 2003, 2004. I was so fat, my jersey split open. I'm fatter now. Okay, I was doing the duathlon, this one. Okay. So the things that we're going to cover today, among the things, the word correlation. That day somebody used the word, somebody posted their objective, and their objective of the study, they mentioned the word correlation. And I said the word correlation is by itself is a statistical test. And what you're trying to do inside your objective is not a correlation, but you're comparing between two groups. So when you're comparing the two groups, it cannot be correlation. Correlation is in the sense that you're trying to find relationship, mencari hubungan. Okay, mencari hubungan, trying to test a relationship between two variables. And they have a positive and negative correlation. We are going to talk what is meant by the positive and what is negative. We're going to talk about race effects. I'm going to touch a bit about outliers. Later on, when we do the regression prediction, we're going to cover about that. Directionality problem, maybe I will cover, maybe not. Third variable problem and partial correlation. I'm not going to cover partial correlation here. I'm just going to cover about the third variable problem due to the time limitation. Okay. So, among the things that is necessary for a correlation to be done, the data must be related pairs. The data must be related pairs. For those doing studies like using questionnaire, like quality of life, then you have many domains. You have domain for mental illness, you have domain for physical fitness, you have domain for social function, you have domain for marital function. So these data are inside the respective domain, and each one have their own score. And you want to find whether there's a relationship between physical measure and mental health measure. Can, because they are related to one another. An easy example, your height and weight. The taller you are, the more weight you gain. Okay? But of course, after the age of 18, you stop growing. Upwards, you just grow sidewards. Okay. So right now, I'm at my largest moment in history. When I was about to get married, I was only 63 kilogram. Now I'm 107 kilogram. MashaAllah. There's a lot of weight to get to lose. So the other thing is you need to, the data should be, again, as mentioned before, it should be continuous in nature. It should be continuous in nature. The scale of measure should be continuous. The data should be distributed normally. Okay. The relationship between the two variables must be linear in nature. The relationship between the two data set must be linear in nature. Okay. Then they must have homoscedasticity. If this is not homosexuality, the word is homoscedasticity. Homoscedasticity indicate there is a single distribution. Okay, we're going to cover that later on. Okay, remember I said there must be a linear relationship. If the data is not linear, like this, you cannot do correlation. You cannot do correlation. This one is a non-linear relationship. We call this the Absorption Law. Okay, when you get too much, it comes down. Okay, this cannot be used for correlation. Okay, you can only use correlation when the relationship is linear in nature. Okay, you can measure stress. You can measure stress. Yes, you have the personal stress inventory, and you can measure the probability of developing illness. Then you can do correlation. Okay, but usually we do it between things that you can measure easily. For example, between your height and weight. Okay, your height is one data, your weight is another data set. Both are continuous in nature, therefore you can use correlation. How about if the data is not continuous data? Instead, it is ordinal data, like your pain score. So it is a pain score, or example given here is work satisfaction. This one is based on Likert scale, and work output based on number of things you can produce in one day. Then one you have to use Spearman or candle rank correlation. Spearman or candle rank correlation. Okay, for those in anesthesiology, you like to use pain intensity, whether mild, moderate, or severe. Okay, and the dosage of pedidine. Of course, the higher the dosage of pedidine, the happier you are. Hoo-ha, hoo-ha. Then this is the mild, moderate, severe is Likert scale, ordinal in nature. Therefore, you cannot use Psn correlation. Instead, you have to use Spearman or candle rank correlation. Okay, so let's look at Psn correlation. As I mentioned just now, it must be between continuous data. Example given was height and weight. Okay. Okay. So let's talk. I remember I said that day somebody was asking about regression to the mean. So the one who focused on this was people like Sir Francis Galton. Okay, this one was a long time ago. Yeah. So Sir Francis Galton is the guy who discovered the fingerprint, and he's very rich. Once he became rich, like all other rich people, they want to waste their money, and he wasted his money by measuring everything and everybody. He even sponsored a group of people to go to Africa, to Congo, to measure the height of the pygmies and to measure the height of the soldiers in the Kenyan military. Okay, so he came out with this, what they call, why? Because he believed that the more measurement you do, the more normally distributed the data will be, and it will be the more likely to be regress to the mean. Okay, so that's the word regression to the mean. Okay, so one of the pet theory of Sir Francis Galton was saying that the height of the father and the height of children are related. The height of the father and the height of children are related. Okay, for me, I'm 176 centimeter if I'm standing on my right leg. Standing left leg, 175. Okay, my children, the tallest is my son Afnan, 168. Okay, the next one is the other son, 167. Okay, so on and so forth. So Sir Francis Galton believed that the height of the father is related with the height of the children. So because it is between relation, so he called the formula co-relation. He called it co-relation. Okay. But when for the second publication, the co-relation, the typist wrongly typed become correlation, CORR. And from that, it became a new word. Instead of correlation, it became a correlation. Okay, and since now the measurement, the Psn correlation is now known as the coefficient of correlation. Okay, so correlation. Okay, just take note of that. So he came out. This thing was it was formulated by Carl Pearson, his disciple, and Carl Pearson handed it over to R.A. Fisher, and R.A. Fisher came out with the geometric formulation. Okay, and it was published in Biometrica. Okay, same like William Silicoset, having published in. And they check everything, they calculate everything, because Pearson was surprised that R.A. Fisher came up with the solution to his problem very fast. Okay. Okay, please take, Pearson called it as Galton's correlation of coefficient, but it is now known as Pearson correlation of coefficient because Pearson was the person who popularized it. This is what we call the Stigler's law. Lembu punya susu, sapi dapat nama. Okay, so here's an example of a correlation between the height and weight. So you can see my height I mentioned was 176, somewhere around here. So by right, my weight is not supposed to exceed 80 kilogram. I'm 107. Woo! Okay, so you can see here, this is what we call a linear relationship. As the height increases, okay, I'm having trouble there. I'm not I don't know whether you can see this on the video or not. Can you see the cursor on the video? Tak ada. Okay, I'm going to ada. Okay. So I'm going to go back and see whether I can go down to the left side. Okay, I'm going to change the cursor. Pointer option, laser pointer. So as the value increases, as the height increases, the weight also increases. You can see, you can draw a straight line here. This is what we call a linear relationship. This is what we call a linear relationship, and it is positive. Why is it positive? As the height increases, the weight also increases. Okay. So how to calculate R? This is the formula. Again, as I mentioned before, don't bother to do it manually. Use Spss. But of course, I like to torture my student. My student have to do this manually. Sorry, mula batuk. Nowadays, a cough is very frightening. Kalau saya batuk banyak sangat nanti, the technician Syam is going to run away. Fitri also going to run away. So better don't cough. Alright, so this is how we do it manually. This is how we do it. And as you can see, it requires a lot of manual calculation. Therefore, don't do manual calculation for the correlation. Okay. What is important here at the end of the day is not the value of the T. What is important here is the value of the R. Okay. My hand smells durian. I don't know where the durian came from. Okay, Fitri dah lari. Okay. So the two pieces of information is the value. So the value is the strength of the relationship and the direction of the relationship. So what is meant by the strength? The R okay, thank you. Okay. The R lies between -1 and +1. The R lies between -1 and +1. The value near to 0 means there is no correlation. Kosong means no correlation. So how I usually explain inside my class? Antara saya dengan Emma Mak Embong, correlation 0. Dia tak tahu pun saya wujud. Okay? So there is no relationship whatsoever. Okay? What is a good, strong, positive correlation? A good, strong, positive correlation is between two persons that support each other. Okay? So you can see, like, for example, our PM is my Sabri, and his supporter, okay, Muhyiddin Yassin, they have a good, strong, positive relationship. Seorang naik, seorang lagi pun naik. Okay. If there is a example of a strong negative correlation, it is between Najib and Mahdi. When Najib goes up, Mahdi goes down. When Mahdi goes up, Najib goes down. So that is a strong negative correlation. Okay. Okay. So that is how we look at relationship. Okay. So how we define the strength of relationship? If the value is 0.8 or higher, we call it very strong. Between 0.6 to 0.8, moderately strong. 0.3 to 0.5, it is fair. Less than 0.3, it is poor. If you look up in terms of other references, if under Cohorts got only 3 groups. For under Cohorts, it is only poor, moderate, and strong. Okay, so but the cutoff point are quite similar. Okay. Direction, positive and negative. If the one value increases, the other value also increases, because that is a positive relationship. So we found out that the higher course entrance exam scores are associated with better course rates during the final exam. Kalau start masuk tu yang pandai, penghujungnya mereka juga akan pandai. If you started as clever, at the end of the day, they are also clever. If you start with low marks, the word stupid sounds very harsh. That one is only applicable to politicians, not to postgrad students. If your mark started low, then your outcome also quite low, because you don't have a very good foundation. A negative correlation is when as one value goes up, the other value comes down. For example, my BMI and my effort tolerance. Last time when my weight is very small, only 63 kilogram, if I have to go up 3 flights of stairs to go up to my asrama, last time my asrama was at B10, tingkat 3. No problem. I just ran up. When I was a matric, I was rumah F in Alam Shah. So it is on the top floor. Rumah C kat bawah, ground floor. Saya dekat atas. I can just run up, no problem. 63 kilogram, very light. But now at the weight of 107 kilogram, even going up 1 flight of stairs to my bedroom is tough. So my children become the word gopher. Afnan, please go for my charger. Afnan, please go for. Okay, so now my son is in Kulim. I miss him a lot because I have to go up the stairs nowadays. Okay, so increase in the BMI is associated with reduced effort tolerance. So as my weight increases, my effort tolerance decreases. All right, so that is negative correlation. So please take note that 0.9 is a very strong positive association, but it does not mean 90%. It does not mean 90%. A negative 0.9 is a very strong negative association, because as one variable rises, the other one falls, but also it has nothing to do with 90%. Okay, you want to talk about percentage, you have to look at the R square. You have to look at the R square. The R square is no longer the coefficient of correlation. Once you square it, it becomes the coefficient of determination. Okay, the portion of variability in one of the variables that can be accounted for by the variability in the second variable. Okay, so for example, if there are of minus 0.5 for depression and CGPA, then when you square it, it becomes 0.25, and 0.5 is 25%. of the variability of the CGPA can be accounted for by depression. So how about the other 75%? Could be other factors like habits, motivation, ability, courses studied, etc. Okay. And you can see if you look at the R square, 0.5 and 0.7. 0.7 is double R square of the 0.5. Okay, here's an example of a study done in Kelantan. We found out that 20% of the variability of the baby's birth weight is determined by the mother's weight. So the mother's nutrition is very important because they have the largest effect on the baby's birth weight. So therefore, we should focus our efforts on the nutrition of the mother so that we end up with healthy babies. Okay, how we get 20%? Please look down here at the bottom there. R square 0.204. So R square is the coefficient of determination. Therefore, 20.4% is coming from there. All right. Okay. So that is the story about the coefficient of determination. Okay. Can you say causality? Cannot. Causality is only based on the design. Can only you can only decide based on the design. If your study is just a cross-section study, you cannot say this one causes the other. Okay. Then you have the directionality of the effect problem, which one causes the other. Okay. And then we have the third variable problem, which may affect the wrong assumption that you made. Okay. I'm going to start with the uh, cross-sectional effect. Okay. For example, given here, you have a fire, and you found out the more firemen you send, the larger is the damage. So is the fireman causing the damage? No, because the bigger is the fire, the more firemen that you send to put out the fire. So you must be very careful. There are people, even R.A. Fisher, who argued that lung cancer is not caused by smoking. They said lung cancer is caused by stress. Okay, so we know already based on the cohort study like Framingham and so forth, they've shown that there is a correlation between lung cancer and smoking. Okay, and this one is based on the cohort study. So if you want to do causation, it should be based on study design like experimental, cohort. Okay, then you can say causation. If it is a cross-section study, cannot. Okay, you can just say it is associated. So further explanation, big fire, more firemen sent, big fire will cause more damage, but not the other way around, of more firemen sent will cause more damage. Okay, so the other thing is about directionally, because you're doing cross-sectional study. You already take note that about 1/3 of you will be doing a cross-section study. So when you're doing a cross-section study, it's very hard to determine which one is the cause, which one is the outcome. Okay, or they may have an effect on each other. Okay, so you have to take note of that. It is only possible to see directionality of the effect if you're doing a cohort study or an experimental study. So for example, class attendance and higher grades. Is it because you attend class, you end up with higher grades? Or you like to attend class because you end up with higher grades? Okay, so kalau datang kelas asyik kena panggil bodoh dengan cikgu, mana nak datang kelas kan? Okay. Or aggressive behavior and due to viewing violent TV, or because of you like to watch, because you are already violent, you like to watch violent TV. Okay, so these are the things that among you have to take note of, which one is which, yang mana menyebabkan yang mana. Okay, there are for things like that, you have to do what we call a cohort study or a longitudinal study. For example, here this one is a longitudinal study done on the same group of people, and they found out that when you are young, you like to watch violent TV, okay, because you cannot be violent yourself. Then if you are violent yourself, your mother or your father will wallop you, okay. But after you have become big, you have masuk form 5 ke apa, you can become the taiko. You can act out your violence on the weaker members of your classroom. Okay, no need to watch violent TV already because you can be aggressive on your own. Okay, so based on the cohort, you can see that. Okay, doctor, you are looking at what? I'm looking at this. So you can see the R here, 0.38. When they are young, they are aggressive. When they are big, they are also still aggressive. So the correlation is there. So those who like violent when they were young, they still end up violent when they are old. Okay. But now, when they are already old, they don't care about violent TV because they can act out the violence themselves. You can see here, the value is negative 0.5. All right. So that is how it is. The other is the third variable problem. Sometimes you don't expect to see the problem. Okay. Inside the classroom, this slide will be nice. But inside a Zoom session, no point. Okay, but I just go through the slides. Okay, the third variable. What is the third variable in this class attendance is GPA? Okay, as you can see, the third variable here is the motivation. Those who like to, those who are highly motivated, end up coming to class. Those who are highly motivated end up with better grade point average. How about number of mods and crime rate? I'm not saying that the more mods you have, the higher is the crime rate. Why? Because the third variable that you're not seeing here is the number of population. So the larger the size of population, the more mods you have. The larger the population, the higher is the crime rate. But of course nowadays banyak masjid pun tak guna kan? Kenapa tak guna? Tak boleh sembahyang. I'm lucky. My room is just behind the surau. So last Friday, although only DJK get to pray, I just pray inside my room because my room is right behind the surau. So boleh sembahyang Jumaat. Alhamdulillah. That's why I don't want to shift. How about ice cream? Why does eating ice cream end up with people drowning? Are they drowning because of the ice cream? Nope. But because of the why people eat ice cream? They eat ice cream when the temperature is hot. Okay, temperature is hot, they eat ice cream. Temperature is hot, they go to swimming pool. Then they end up with drowning. But of course nowadays with COVID, nak pergi pool pun tak boleh. Dah 18 bulan saya tak pergi swimming. Sial saya kan. I like swimming, why? I'm like the ikan paus. I can float easily. Alright, and with that, I think we can end the correlation part. Okay, I have to end this fast because okay, just take note, if your data is normal, you can do correlation, Psn correlation. If data is not normal, you use Spearman correlation. And with that, again, I'm giving you the notes on how to do SPSS, free, no charge. As you can see, it is very easy to use SPSS to calculate the correlation. Senang saja. Terus dapat result. Tak payah kira apa-apa. Okay. And they also give you a diagram, the scatter diagram. Okay. I'm not going to cover Spearman. Okay. Just take note that it is the non-parametric version of the Psn correlation. Okay. The notes are there, but I'm not going to cover because you're not going to use it anyway. Okay, let's go to linear regression. So linear regression is the extension of correlation. If you do a correlation, you find that there is a significant correlation. Therefore, you can predict the outcome based on the risk factor. I repeat, if there is a correlation, if there is a significant relationship between two variables, if the R square is quite large, therefore you can predict the outcome based on the risk factor. So linear regression is an extension of the correlation in the sense that they give you the ability to calculate. Okay, here's the example given, cholesterol and age. Okay, as we all know, kita ni macam kelapa. Lagi tua, lagi berminyak. We are like coconut. The more mature you are, the more oil we have inside our coconut. Okay. So the older you are, the higher is the cholesterol level. So you can use correlation to predict that. But if you are trying to describe the relationship in more detail, then you will do a regression. Okay, here's the example given. Relationship between age and cholesterol, and you have the scatter diagram there. Okay, I'm not going to worry about this so much. We already covered under correlation. How we do it inside Spss, very easy. You just click on, you do a scatter plot. The X is the risk factor, Y is the outcome. Here, age is the risk factor, cholesterol is the outcome. You put it inside there, you plot it, you get the table. You get the graph, the scatter diagram. You want to do the simple linear regression, even easier. Click the button Analyze, select Regression, select Linear, put in the risk factor. Okay, where is the risk factor? Okay, let me find the mouse. Okay, this is the cursor. So the dependent is the outcome. Independent is the risk factor. So you put in the cholesterol level in the dependent, you put in the age inside the risk factor. Then you run the analysis, you get the value. So they're saying that the cholesterol is determined by the constant of 5.9 plus, in bracket, 0.058 times age. So if I'm the age of 54, let's make it easier. Let's make it 50. So 50 plus 0.06. So my cholesterol will increase by 0.3. My cholesterol will increase by 0. So 5.9 plus 0.3. So my cholesterol should be around 6.2. Okay. Is it true? Not really. Why? Because I'm already on Crestor and now I'm on Lipitor. Why I stop taking Crestor? Crestor kena beli. Lipitor free. Okay. Which one is better? Crestor or Lipitor? Crestor is better. But both Crestor and Lipitor plays havoc on my knee joints. Okay. Sekarang sembahyang pun susah. Okay, this one is the effect on the, you can see here, as you increase by 1 year, it is 0.06. But if you increase by 10 years, increase by 0.6. Okay, so that is the linear regression, where you can calculate the outcome based on the risk factor. How they come up with the line? The computer will do it for you. They call it the LSD, least square differences. Okay, LSD, not the drug. The LSD here is the least square differences. Okay, of course you all don't know what is LSD lah. You guys are the new generation. They know ecstasy only and the speed pills. Fitri tahu LSD tu apa? You should know. Then you can. Okay, so we use the LSD here in the least square differences. They just select the best line. So don't worry about this. Computer will do it for you. Okay, computer will do it for you. So they just find the best line to get the one with the least differences, and that one will give you the best line. Okay, the smaller the sum of the differences, the better the fit of the line to the data. Okay, so some of you was asking about Manova Mix Effect. So it is somewhere along this basis of multiple linear regression. You have to take note that the outcome is never caused by only one risk factor. It's always multifactorial, caused by many factors. For example, cholesterol level is determined by diet, exercise, socioeconomic status, age. One variable missing from here, you know what? BMI. Okay, BMI. The higher the BMI, the higher is your cholesterol level. Why? You got so many spare tire. Okay. Alright. Okay. So this one, therefore, because of this, you should run the MLR whenever you're doing your analysis. So just like your friend asking about the mix effect or the mix Manova. Okay. When they say mix, they're referring to the covariates and the factorial. Okay. So I'm not going to cover so much about this, but just take note. You have to do multiple linear regression or any other multivariate analysis after you have done your initial test, because you have to control for confounders. Okay, so if everything is just continuous data, we call it multiple linear regression. If it is a mix of categorical and continuous data, we call it a general linear regression. So I'm not going to focus so much about this. Okay, I know I already exceeded my time. 2 minutes lagi. Okay, alright. And with that, we got, I think, scatter plot. Okay, so usually what we do whenever we run the analysis, we do a scatter plot, see whether the relationship is linear or not. If the relationship is linear, then we see whether it is positive or negative. Then after that, you can do the analysis of the simple linear regression using the Spss. Okay, very simple. You can just select analyze regression linear. Then under the dependent, you put in cholesterol. Under the risk factor, you put age. The risk factor here is independent. You can click on estimates. You can click on the CI. Then you get the answer down there. So you can see that it's given to you automatically. You have the constant of 5.8, and you have the regression the regression coefficient of 5.77 times 10 by minus 2 times 10 minus 2 by the power minus 2. All right. Okay, and then you will plot the table accordingly, something like this. Okay, for your multiple linear regression. So just remember, it is the formula is y equals a plus bx. Y is the outcome, a is the constant where the line crosses the y-axis, b is the slope of the line, the rise or the run. Okay, so therefore, if you have the value of x, you can predict the value of y. This is a formula, how you calculate manually. Of course, I'm not going to ask you to calculate manually. Please use Spss. Okay, otherwise you're going to die an early death due to stress. Okay, to be frank with you, the formula is long-winded. You have to test for the t, see whether the b, the beta, the regression coefficient is different than 0 or not. You have to do the s residuals. You have to calculate the y fit and the y, and you have to get the difference. After you get the difference, you have to sum it up, put into the formula. So you're going to end up causing a lot of stress for no reason whatsoever. Okay, so the best thing, just do the whole thing using Spss. Just take note which one is A, which one is B, which one is the p-value, and then you are okay. All right, and okay, welcome, KD. He's back from quarantine. If anybody has to be worried, is when KD entered the room, I think I should put on my mask. Okay, and here's an example of an exercise that is using the regression coefficient. You can see here, here in this analysis, the outcome is birth weight. Okay, so the birth weight is based on the 1.615. 1.615 came from here from the constant. Then the BMI is here. The regression coefficient BMI is 0.049. So put into the formula, and then that is how you calculate the birth weight of the baby. So the birth weight of the baby is dependent on the constant of 1.615 and 0.05 of the mother's BMI. And with that, thank you very much. I know I went a bit fast, but don't worry, You have the video here, and we will upload it tonight when Afiq email it to me. Afiq is very good. 2 o'clock he already emailed them. Okay. Okay, thank you. All yours. I'm going to stop sharing.
Okay, thank you very much, Prof. So I think we have two questions. The first one is, can the third variable be tested as well by the regression analysis?
Okay. Okay. The third variable can be tested by doing a multiple linear regression. So basically, what happened? You run the you can test all the correlation, get the correlation, and then you will combine all this analysis together inside a multiple linear regression. So when you put in all the variables together. If the variable is not significant, the p-value will not be significant. Therefore, you can omit it from your analysis. Okay. So the third variable can be detected. So for continuous data, you can test it using multiple linear regression, or you can use GLM, general linear model. If it is the data is categorical and the risk factors are all categorical, you can do mental Hansel. You can do mental Hansel. You can check out the notes on mental Hansel and GLM and multiple linear regression on my website. And my website is drtamil.me, as Dr. Fitri has kindly posted earlier.
Prof, for the second correlation comparison for nonlinear data.
Okay. Thank you. Afiq got distracted. That's why he did not mute my mic when Fitri was talking. So I just repeat back there is no correlation comparison for nonlinear data. For nonlinear data, as mentioned, if you want to do correlation, we have two analyses. One is Spearman correlation, and the other one is candle rank correlation. It is very simple. You just click on correlation inside the Spss. There's a button to tick: Pearson, candle, or Spearman, and you can do for all. For those who pray for my good health, Alhamdulillah, thank you very much. Okay.
Okay. Yeah, thank you very much, Prof. I think we have no other questions. So now we will have a 20-minute breaks. So we will come back at 10:50 a.m. today. Okay. So thank you very much.
Boleh stop dulu. Okay. 20 minit break. Ya, makan tu.
Prof, kami kena jumpa ketua kamera tau.
Okay.
Kali dekat pada office.
Alright. kata punca jangkitan tu lari je. Okay. Apa? Dia sebab dia tegang. Okay. Itu kena lighting tu, bawah kanan.
Tak jadi hitam.
Tu yang apalah. Takkan semua aku nak bawa ini.
Tak ada orang lah. Kita berdua je lah.
Kali ada. Kami habis ni kami datang sini.
Jadi kita tak ada dapat kami. Okey.
Habis
dia mau habis kualiti sebab dia apa? Hiring orang.
Prof, pasal nak bincang ketua baru dengan tugas.
So bagi mangkuk 29.
Saya masuk ni, Wan. Saya sampai masuk balikan.
Yang ada dia boleh.
Saya aku nak balikan.
Kali dia kontrol kat office lah. Nak datang kat tak boleh dia hiring. Tu kan kena kat sini tu tahu. Nak masuk office kena dulu. Dia kontak dengan satu.
Roommate.
Dia.
Dia duduk rumah bujang.
Dia kan kahwin ke? Dia dah. Oh, okey. Okey.
Tu sebab tiba-tiba dia kurus, macho. Nak
Itulah,
cari kan,
sebab
nak cari.
baju pun yang lain bro. Jadi dah ketat sikit.
Slim fit. Kamera aku tak off. Dah off? Oh, ni share.
Ni sebab nak tengok anak ni pasal baru nak register lah. Kalau tak memang tak lah. Itu apa? Vaksin lah. Dia tak cucuk lagi. Dia tak cucuk. Oh, okey. Sebab tu kita tak bagi cucuk. Sebab tu lagi lah. Oh, dia tak cucuk lagi.
Anti-vax in group.
Nanti kau
Ya.
Apa ni? Macam mana kena MSC tu?
Dia okey, yang dah cukup ni.
Dia kata kalau dia tak nak guna rabu ni.
Kita dah
Makan dah tu, makan.
Really?
Sebab saya pakai Validity.
Ada dah. Saya dah rasmi dah tadi.
Oh dah.
Kalau tak kita ambil balik ID tu, kita buat
Adalah.
simposium.
Aku je ayat sini senang. Allah ni.
Tadi kali kata tu. Pakai webpack.
Dia pakai apa? Sekejap, pasal tadi yang kau tengah ada minat kan?
Ada aku tahu.
Dekat dia tutup bro.
Apa?
Mic juga dah. Okey. Pasal dia buat tu. Tak, kita orang okey dia buat duit ada, tapi dia tu kita nak lipat bagi cash.
Tak, aku aja tak
Bro, kan solution.
Bro, kan kita cakap kena sedih apa kan. Kena sedih. Kena belajar domino sedih.
Mana?
Serius.
Terang banyak ni. Okey.
Tak ada.
Tapi itulah domino kita tak nak claim by ni.
Tak ada apa isap.
Ya.
Tak payah.
Aku tengah jaga makan.
Bro, jangan bro, tak ada kena. Bukanlah kena ni.
Macam aku.
Bro apa? Perempuan. Wan Maslina. Mesej saya. Kena jaga makan. Aku ada. Dia kata dia sanggup bagi 500 dekat
Kita hidup. Kalau problem tak ada nanti apalah nasib orang next year.
Ramai gaji. Esok.
statistik apa bro? Bro,
Fazilah ada. Kalau kau nak yang ngajar best, tangkap Fazilah. Kalau kau nak yang ngajar yang
Biasa kan?
yang buat sakit hati, kau panggil Nazar.
Nazar
Nazano, just kat mata tu.
Oh Nazar.
Nazar tu kan. Tu pun tak tahu. Balik baca sini. Aku sampai student mesej aku. Doktor, kesian lagi tu orang ni tengah
Dia dengan student dia dengan dia takkan nak.
ya dia buat. So, apa aku dapat mesej, lepas tu dia komplain dekat ketua jabatan. So, Hashim datang panggil aku. Saya tak tulis. Saya tahu kamu yang paling senior, tapi saya nak kamu ambil ahli basic statistik. Lepas tu yang sampai sekarang aku gaduh dengan Samsul, sebab Samsul ketua unit. Hashim bagi arahan direct dekat aku. Tak lalu Samsul. Samsul pengarah pasal tiba si Azmi ambil ahli basic. Aku cakap dia, tak apa-apa gaduh-gaduh. Kerja tambah kan. Aku pun tak nak kerja banyak kan. Aku boleh tak taji semua budak ni. Kau tengok. Padahal aku yang paling senior, tapi yang ajar semua seorang buat.
MNA macam ni.
Ambil nanti masa break, masa habis sesi
Dua hari
kita akan show kan.
So, aku tak lagi dua habis sesi ni.
Habis sesi tengah hari lah, dia tengah hari ni. Bila berapa habis? Just
Nanti berapa dengan doktor tu lah?
20.
Penurut aku tak
Lepas tu
tahu.
kita
Kalau saya jawab kan yang betul guna webex ke
QR code juga lah kan.
hari Rabu ni. Kalau tak guna hari Rabu ni webinar, baik hari ni.
Buat simposium tu, bro. Sampai susah juga ambil dia.
Saya nak balik office ni, ada meeting.
So aku tanya salam sis. Khalid
Kali-kali.
Khalid
Cakap
Khalid kata you all pakai Webex.
so nak confirm kan webex ke?
Jadi today kami akan release webinar untuk research week.
Tadi gizi je tau.
Macam tu je. Kau jangan tanya-tanya. Dia bagi jawab ya tidak So salam saya sekali kata you all pakai website, jadi kami akan release webinar untuk research week.
Keras
Alright. Biar Khalid jawab. Aku tengah ngajar banyak soalan keluar.
Kalau kali dia macam produk dia kan. Okey, dia bincang.
Dia cepat dari tangkap bila dia on.
Sebab dia masa saya kat FSK pun dia antara tim technical lah. Kita orang yang control PA system apa kan. Betul lah. So kalau benda-benda macam tu.
Lupa nak ambil gambar ni. Biasa aku ambil gambar.
Ha? Ada dia putih-putih ke set.
Tak ambil gambar food.
Itu kan betul.
Tak masuk pula right.
Semua tu benda susah jawab ni.
Aku dah buat slide. Berpakaian setiap hari.
Oh, kau tengok ambil.
Ambil cantik sikit bro.
Yelah dah ambil estetik dia ni. Bukan. Dia okey lah aku ambil aku dah makan tu. Kau ambil yang fresh ni.
Pak Mahir ni dah cakap dah. Malik dah cakap dah dengan kereta kau tak cakap. Tapi dia tak bagi macam ni.
Tak, yang sedap tu dia. Siapa yang komen tu? Apa saya gantung kat tepi? Tak tahu kan? Kau yang komen.
Tadi pun saya jumpa dengan kereta dia tu.
Kita dah cakap dah. Air dia mama.
Gantung lah.
Iya, tak dia cawan.
Tak, sebab letak atas meja tak boleh sebab dia dah macam
Tadi sepatutnya kan biasa orang
lagi.
lagi. Jangan cawan.
Tak, itu kata dia tak ada pun.
Tadi bukan tak, dia alasan tadi. Dia cakap saya nak alik.
Susah nak bawa.
Bukan.
Tak, pasal
Covid ni.
Covid ni. Nak hantar, nak ambil.
Nak
Tak,
dia
tak
tu.
dapat.
Dia cakap dia tu.
Pakai kad. Okey, kau pakai kad kasih kan. Kau boleh masuk kad, tutup.
Dia susah nak bawa. Yang tu aku cakap juga yang tutup tu. Nak bawa.
Tak bawa pun tu.
Kereta dia tak pernah buat tu. Dia
Tak, aku balik best tu. Siapa kata? Ni saya kau.
bukan. Bukan, Prof. Saya tak kenal. Lupa-lupa je media kenal. Saya tak kenal. Tapi bila jumpa tadi, baru tahu. Saya tak nak jumpa dia.
Kenapa dia bagi tahu?
Kak Pau dia aku punya lelaki.
Kalau pakai kad tu, dia masuk dalam plastik yang panjang kan. Tinggi.
Oh, masa ada
tiga.
Dia tak nak. Tadi dia hari tu Malik dah cakap dengan dia. Tadi aku panggil dengan Malik.
Jawapan apa?
Jadi bukan kata tak boleh, tak nak itu. Sebenarnya boleh.
Kau sendiri tak.
Betul tak? Kau beli plastik.
Kalau tidak kan, takkan dia buih tu dia letak macam tu je kau tengok. Macam beli dia kat mana tau.
Ini beli kat dia masuk je. Ini memang tu.
Tak ada nak kan. Kau tahu kan? Tak kan cuma.
Dia tak boleh pakai sambal, puasin.
Kan, saya makan dan
Oh, dia. Prof, warga boleh ke buat check up? Untuk anak?
Anak berapa umur?
Tak, saya orang boleh.
Tak. Umur berapa?
18.
Okay, kau dah minta extend tak? Okay, kau kena minta extend. Kau pergi dekat bahagian website yang terbagi tu. Kau minta bahawa kau kena contact dulu yang orang yang Sarawak tu yang jaga sekarang representative tu. Kau kena email kat dia nama anak kau, surat poli tu. Kata anak saya dapat sambung belajar, jadi saya mengikut standing order anak saya akan layak coverage sampai umur 21.
Oh, boleh extend ke 21?
Lepas tu bila dah ada tu dia akan lepas tu keluar GM kau boleh bawa anak kau pergi standing order. Kau tak ada reject sebab dia kata dah tak cover.
Lama ke dia jawab?
Aku punya siap dalam 2 hari, 1 hari lah. Tapi nak cepat kau
Call.
message lepas tu call. Email lepas tu call. Kau tak banyak suami ni nak kena tahu anak aku orang reject.
So nak isteri, nak apa tu kan.
Sekarang ni aku main backdoor lah. Ambil borang, sign sendiri isi semua. Lepas tu dapat result tu, minta member sesiapa sign. Sebab memang kelakkan memang layak. Tapi buat training order banyak suami. Aku saya buat training order tu. Kalau ada sambung belajar, extend sampai modul 1. Dan training order tu dia. Tapi kau tahu lah dia orang, tak boleh, bagian HR kata tak boleh. Dulu anak aku kena masuk hospital. So aku guna tu. So tak duduk third class, tapi dengan surat aku dapat masuk first class. Sekarang semua anak kau tak layak. Dah semua dah, yang paling kecil pun dah 21 lah. Air bulan.
Dah pening sekarang ni bro. Anak-anak dah, dia nak buat keputusan sendiri. Dia dapat UM tak nak pergi.
UM the best.
Dia takut.
Takut tak lulus.
Sebab tahu dah.
Nampak dekat dalam tu.
Ni, dah off kan?
Sekarang ni sebab saya
Dia boleh detect motion
Yep.
Dah dia ambil poli.
Aku tak kata apa lah sebab poli lagi senang kerja kan. Poli lagi senang kerja. Anak aku engineer. Tapi
First poli ke U?
dia U, tapi bila dia masuk kerja, budak-budak poli lagi cepat masuk kerja. So dia jadi bos anak aku tu. Dia bengang lah. Budak-budak poli sound dia.
Dia cakap memang dia tak nak. Tu tak nak, tak boleh cakap apa. Dulu medical student dulu banyak juga kita orang bawa pergi counselling di sini. Macam mak dia suruh, bapak dia suruh, dia tak boleh bawa. Macam tu. Kesal juga.
Memang zaman aku dulu
ikutnya. Sekarang ni
bapak aku senang kan. Kalau kau tak nak buat media, bapak tak nak sign kau punya buat GPA. Dulu tak ada GPA, tak boleh masuk U. Kau bayang lah. Dulu, so walaupun aku tak buat media, tak gerak kak. Terpaksa. Aku tak nak jadi bomoh tepi jalan kan.
orang semua kejar nak pergi masa CU dia tak nak takut dia nak sudah.
Anak aku nombor 1 UKM, nombor 2 UKM, nombor 3 tak layak UKM sebab dia OKU. So masuk Seri. Nombor 4 masuk UKM.
Tak layak sebab OKU.
Dia apa namanya? ADHD, Attention Deficit Disorder.
Tak boleh
Dia sebab UKM dia syarat dia walaupun dia OKU, tapi sebab dia bila dia OKU dia tak boleh nak buat BM tau.
okey.
Dia BM dia cukup PAS ya. Tak cukup gaji, so tak boleh.
Sebab tu lah.
Kesian dia. Yang OKU dia dapat kerja jauh mak bapak. Yang normal pun duduk mak bapak dia.
Dua tiap hari. Lelaki bang.
Masa nak hantar dia kerja tu, boleh marah aku kenapa kena hantar anak aku. Aku tunjuk kat dia. Kata dia OKU, tak ganti. Kan dia bodoh dia orang sepanjang highway tu. So, dia bagi we, lepas dia marah, boleh marah pun. Dah tahu anak OKU kenapa tak simpan kat rumah. Nampak tak jawab. Aku jawab balik, takkan nak suruh dia buat Grab. Ya. Dia survive. Tapi dia mak bapak call. Mak call. Lepas tu patau pakai CCTV. Di rumah.
Berumur. Baru lagi ke?
Dah bulan 6 lebih.
Oh, baru lagi lah.
Yang paling sial tu polis. Aku nak bawa 2 kereta. Boleh drive balik kan. Polis kata tak boleh. Kau balik kau naik flight. Polis tanya kenapa anak aku tak boleh drive. Sebenarnya kata kalau setengah jam drive tu okey lagi. Ni 4 jam nak drive, takut dia tak boleh fokus. Lepas tu kita tahu terowong. Bagi 5 minit agak kaya. Kita ada. Kabur curut sini ni belah.
Sekarang ramai yang buat kelompok tu.
Nah, bergilir lah.
Biasanya boleh dapat tu. Itu juga pakai minta form. Boleh. Dorang mungkin.
Boleh je.
Boleh
Ha.
Okey. Saya suka juga. Saya macam asyik pakai yang keminggu
Ya. Boleh je.
Ini pun saya sajalah mungkin sebab macam seluar saya ni dah tak muat sebenarnya. Saya tak boleh. Yang lain semua macam dah baik apa cuci. Jadi pakai lah ni tak nampak.
Tak, tanya Crosby. Pendapat antara UM dengan poli macam mana?
Okey.
Sebab anak saya dia dapat UM, dapat poli. Mula-mula dia nak UM. Lepas tu dapat poli offer, dia nak pergi poli pula.
Okey. Dia lebih kepada praktikal lah. Dia suka praktikal kan.
Dia perempuan. Tapi tahulah dan sebabnya dia sebelum ni dia minatkan akaun. Saya cakap okey kau minat akaun, minta lah kat UM ke UiTM mana. Dapat UM. Bukan melalui UPU lah. UM mohon sendiri tu dapat. Lepas tu dapat poli pula. Oh tak nak lah UM dia tak bahasa Inggeris. Saya cakap
tapi kos yang sama ke?
Tak lain.
Yang lain lah.
Yang ni macam dia kejuruteraan alam sekitar punya ni. Dia cakap ni cabar sikit dia cakap macam tu. Dia ni tak pernah pula. Biasanya dia lemah lembut, suka ni macam akaun okey lah bagi saya. Dia okey lah kalau akaun. Tapi dia dah dapat poli ni, dia macam dah lain pula dia punya arah tuju. Saya cakap macam mana tu? Tanya. Orang cakap tak payah. Sekarang ni trend sekarang ikut dia. Kalau kita paksa pun, kalau dia tak nak sekat jalan, macam mana?
Dia poli tu CJ kan?
Tak. Diploma juga.
Poli diploma.
Tapi UM lagi untung. Sebab dia offer kat situ 2 tahun diploma.
Ini 3 tahun.
3 tahun.
Okey.
Itu masalah tu.
Tengok apa yang dia nak lah kot.
Sebabnya pengalaman saya masa duduk secretaries dulu, kerja dekat jabatan secretary, ramai juga medical student duduk kita panggil pasal ni. Dia cakap dia memang tak minat, mak yang suruh, bapak yang suruh. Macam tu. Masa duduk secretary selalulah macam tu.
Dia pun tahu.
Kita mengira.
Boleh.
Okey Prof, boleh.
Sekejap. Kasih pakai headset. Okay.
Assalamualaikum and good morning everyone. Welcome back. So now we are going to proceed with our next session, non-parametric test. So please welcome Prof. Azmi.
Okay, thank you Fitri, our chairperson for today. Okay. So right now everything looks a bit different because I still have the wrong background. Okay. Allow me to change the slide. Of all the lectures, this is the worst lecture lah. I usually what I do the last time, whenever I'm asked to give this topic, I will tai chi this to someone else. But I think they knew my trick already, so now everybody refused to take over this slot. So it has come back to me. Okay, so I'm going to change the slide now. Wow, MMA came out already. Oh, that's very nice. Ayo, Kaidi cancel it out just now. Okay, okay. Gelak Kaidi. He's a tease. Suka mengusik. Alright. So right now we are going to go back to the slot. Okay. How I can pull this thing off? I use a special software. They call it Obs Studio. So this software, Obs Studio, allows me to merge the PowerPoint and the video together. So that's why you can see this, me and the PowerPoint together. At my back is a green screen. Dekat belakang saya adalah screen hijau. So allow me to show you how it looks like. Okay. So that's the green screen. So you can see that behind me is the green screen. So once I enable what you call the chroma key, the green screen changes, and you get my video and the PowerPoint together. Okay, so how much does it cost to get a green screen? It is only 20 ringgit on Lazada. You can check it out. But of course, for the faculty, takkan nak beli yang 20 ringgit kan? So we ask for a green screen yang harga 1,500. Best sikit, mahal kan? Beli barang mahal kan? Alright, so the nice thing about this green screen, it is portable and we can dismantle it and bring it around. So we can use it at the bilik tali sidang, we can use it inside the auditorium, so on and so forth. Okay, I'm going to share my screen now. Okay. The reason why you're not seeing much difference is because my video was already spotlighted. That's why you saw the same one. What's the advantage of me sharing the screen? Hopefully the words are clearer when I share the screen. Okay. All right. Okay, I need to shift this thing aside first. Otherwise I cannot see the PowerPoint. Okay. So when we talk about non-parametric analysis, non-parametric is the other version of of a statistical test. So what we have covered from Friday until today are all the parametric tests. So when we talk about student-state test, that is a parametric test. When we talk about Psn correlation, that is a parametric test. When we talk about PET test, that is a parametric test. So for every one of the parametric tests, there is a non-parametric equivalent. For every parametric test that we have a non-parametric equivalent. Okay, so for the non-parametric equivalent is the Wicorsen test and the Kruskal-Wallis test. Okay, so if you remember back when we had the lecture last Friday, we talked about data exploration. We talked about testing for the distribution. Okay, we talked about screening for errors and correct them. Okay, and if the data is not normal, you cannot use parametric analysis. You can use non-parametric analysis. Okay, so now I'm going to cover the non-parametric analysis. Okay, so as mentioned earlier, There are so many statistical tests. Your biggest problem is to decide which one is the appropriate statistical test. Okay, which one is the appropriate statistical test? So how you decide which one is the appropriate one? You have to look at the number of the observations available inside there. Okay, you have to look at the number, how many independent groups you have, how many dependent groups you have, the type of data, whether it's continuous or categorical. Okay, I know the word to use is quantitative and qualitative, but the word quantitative and qualitative does not sound so different. So I rather use the word numerical and categorical, because numerical numbers, categorical categories, quite clear. Then we look at the data, whether it's normally distributed or not, and of course we look at the objective analysis. So why we do non-parametric? We mentioned already, if your data is not normally distributed, you can only do non-parametric analysis. Okay, so one example is the Wicorsen rank sum test. As mentioned here, it is based on analysis of ranks. Okay, so who end up having to do this non-parametric analysis? Usually people who do animal studies. People who do animal studies. Why? Your sample is very small. It's, 9 rats, ataupun 9 guinea pigs, so on so forth. So very few. So you have to do non-parametric analysis. Okay. So what are the non-parametric analysis? One is facial exact test, which we already covered last Friday. Okay. Then we have the Wicorsen rank sum test. We have the Kruskal-Wallis one-way Anova test. We have the Wicorsen sign rank test. For the Spearman and Psn correlation, we touched a bit earlier when we were doing the Psn correlation just now. Okay. So now what's left is only the Wicorsen rank sum test, and Wicorsen sign rank test, and the Kruskal-Wallis. Those are the only analysis that we're going to cover now, because the rest has been covered earlier. Okay, what's the advantage of using non-parametric test? Last time, before the age of computer, it is easier to calculate. Why? So because when you do manual calculation, and there's no need for you to calculate the mean, there's no need to calculate the standard deviation. You just arrange the numbers, then you sum up the ranks, then you get the p-value. So very easy. Okay, it is very easy. But if your data already started, you already have all the data in in continuous nature. For example, the data you have the BMI. You already have the BMI. Then suddenly you want to decide to analyze using overweight and normal. You must have a good reason for that. If there's a good reason, then you can go ahead and do that. But otherwise, better to keep the data in its original form, which is the numeric data. Okay. Just take note, non-parametric test is only suitable for small data set. Most of the tables are maximum number of number of samples is only for 30 or less. So if your samples are larger than 30, the tables are not widely available, so it is very hard to calculate manually. Can you calculate the non-parametric test using Spss? Can, but not much to discuss. They just give you the Z value or the P value. So there's nothing to discuss. Absolutely nothing to discuss. Okay, so let's start with the first one. Okay, the first one is the Mann-Whitney U test. also known as the Wicorsen rank sum test. So last time they call it Wicorsen rank sum test, but because when we do say the Wicorsen test, people confuse whether it is for Wicorsen rank sum test or Wicorsen sign rank test. So they came up with the other name of Mann-Whitney U test. Basically, Frank Wilcoxon is from UK. Mann and Whitney, they are from the East Coast and West Coast of America. Frank Wilcoxon came up with this test earlier than Mann and Whitney. Okay, so those from the American continent, they tend to use Mann-Whitney U test. Those from the British area tend to use Wilcoxon rank sum test. Okay, so that's the difference. Why Wilcoxon rank sum test or why Mann-Whitney U test. SPSS is a software designed by Americans. So inside SPSS, they use the Mann-Whitney U test. Okay? So that's the difference. That's a cultural difference. Just take note of that. So why am I using Frank Wilcoxon? I think Frank Wilcoxon deserves the honor. He is the guy who came up with the papers first about this. All right. So how it is done? Simple. How? Because basically they just arrange the data from the smallest to the largest. That's the key point. From the smallest to the largest, not the other way around. Okay, these are everything. I'm not going to worry about this. These are all the assumptions. So what we do? We assign the ranks 1, 2, 3. So the smallest value get the rank of 1. Okay. Then you sum up the ranks for each group. For the example, I have a very small data set. These are between taxi drivers and bus drivers. Okay, there are only how many? 1, 2, 3, only 8 of them. Okay. So we have the taxi drivers and bus drivers. We have the glucose level. Doctor, the glucose level looks weird. This was in the milligram per deciliter. The study was done way back in 1992. At that time, they still don't have international unit. They're still using the milligram per deciliter. Okay, so we have these values 124, 141, 93.6, 139, 104. So, okay, if like for us nowadays, is millimole per liter. Is much lower. Yeah? For example, my blood glucose should be around 5.8. So this one is in the old unit is milligram per deciliter. Okay, let's look at the analysis. Let's not worry about that. Haha, tak jalan. Okay, so we arrange the data in ascending order from the smallest to the largest. So smallest of 93.6, the largest is 141. So we just arrange the data set. Okay. After you arrange the data set, you just give the rank. So the smallest get the rank of 1, the largest get a rank of 8. Why? Because there are 8 data set. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. Okay, what is the smaller group? The smaller group is I think this is one is bus driver. So the bus driver, there's only 3 of them. So the rank of the sum of the rank is 1 plus 6, 7. 7 plus 8 is 15. Okay, 7 plus 8 is 15. Okay, so you can see here 1 plus 6 plus 8 equals to 15. This is a smaller group. So now we have to convert the sum of the rank, from t value to become p value. For that, we need to refer to the table. The table looks like this. So you can see here the value 3 and 5. Value 3 and 5. So they say it is only significant if the value is 6 or smaller or 21 or larger. The values are the t value is significant only if it is 6 or smaller, 21 or larger. But we got 15, so 15 is somewhere in between. So it is not significant. It is not. So therefore, P is larger than 0.05. So there is no difference of the glucose level between the bus driver and taxi driver. Okay. So what do we do? Okay, if you conclude, it's like that. Simple. It is simple, which is a null hypothesis not rejected. So how to present? You will present the median of the values between the two groups. Okay, you present the values of the two groups. All right. So if you run the Spss, okay, it'll be under analyze non-parametric. Analyze non-parametric. You get these results. It looks like this. Okay, it looks like this. So the same as you can see. Remember we had the rank of 15. So this one is the mean rank. So 15 means 5 times 3, that's 15. Okay, so this is the mean rank. So the sum of ranks is this one, 15. So this is also how we get the p-value, and the p-value, as mentioned just now, down there is larger than 0.05, which is the value of the p is 0.8786. Okay. Okay. Therefore, it is not significant. So the problem with non-parametric test, it is very hard to get significant because you must get all the data in certain order. They must all be lumped into one end or the other. So the only way for the result to be significant is for all the data of the smallest group to be at one end or the other. Either they are all at the top or they are all at the bottom. Like this. If they are all at the top, okay, 1, 2, 3, then they are significant. Why significant? 1 plus 2 plus 3 is 6. So as you can see, 6 significant. 6 is P smaller than 0.05. Okay? Or they are all at the bottom. If they are all at the bottom, 6, 7, and 8. Okay? 6, 7, and 8. So 6, 7, and 8. 6 plus 7 is 13. 13 plus 8 is 21. As you can see from the result, 21 significant. 21 significant. Why? Because the table says 21 or larger. So what is the point I'm trying to show here? I'm trying to tell you all, if you're doing an analysis using a small sample size, the only way for you to get it to become significant if the data are skewed to one end or the other. If they are distributed to one end or the other. Otherwise, very hard to get it to be significant. That is why I don't like to do non-parametric tests. Okay. The other one is, of course, because very hard to goreng lah. There's nothing to discuss. You only have the median, you have the p-value. All right. So how about if you, instead of only 2 groups, you got 3 or more? If you have 3 or more, then you have to do the Kruskal-Wallis one-way Anova test. I repeat, if you have 3 or more independent groups observation, you have to do Kruskal-Wallis one-way Anova test. Okay. Again, this is a non-parametric test. They use the chi-square distribution to approximate if each sample size is what we expect to be. How they use, which degree of freedom to use, it is the number of group minus 1. So if you got 3 groups, then you minus 1, so then your degree of freedom is 2. C refers to number of groups, okay? Okay, same assumption as before. They must be independent. Okay. Okay. So what's the problem? The problem is this formula. I know it looks nice, but the formula is wrong because they don't have the brackets. So yeah, in fact, they have three components that have to be done separately. So this is one component. Sorry. This is one component. This is another component. The one in the middle there, another component. And this is the third component. So they have to be put inside bracket and analyzed separately before you sum up together. Okay. So here's the example. We have three machines. Of the three machines, they have different filling up time. Okay. So you had 15 staff. You get these 15 staff to fill up the three different machines. So you end up with 5 workers per machine. So you measure the filling time. So you can get the results like this. Okay. So all the different filling time, what happened? You will have to rank them. Same like what we do with the Man-Whitney test or the Wicorsen rank sum test. Start with the smallest, then give the rank accordingly. So 1, 2, 3, 4, 5, 6, 7, and so forth, based on the values. Okay, these are the values. We give the rank. So what do we do? We take the sum of the ranks. We take the sum of the ranks, same like what we did in Man-Whitney test. We take the sum of the ranks. So this sum of the ranks, I put into the formula. As you can see, I have added the brackets there. Okay. Otherwise, you can never get the answers. So once you put in the brackets, you can see I get the value of 11.58, and this 11.58 you put into the, you look at the chi-square table for degree of freedom of 2. Chi-square table for degree of freedom of 2, the cutoff point is 5.99. So h of 11.58 is larger than 5.99. Therefore, you can conclude that the median filling time between the three machines is different. Okay. But of course, you cannot decide which is fastest unless you do what we call the Wicorsen rank sum test one by one. For machine 1 against machine 2, machine 2 against machine 3, machine 1 against machine 3. Okay. So that is how we do the Kruskal-Wallis one-way Anova test. Okay. Is the test available inside Spss? Yes. When you run it using Spss, you get answers like this. This is exactly the same output. Again, you get the sum of the rank. So you can see the sum of the rank. You have to get this one times 5, this one times 5, this one times 5. Then you can get the sum of the rank. Okay. Again, we got the same answers like what they got. They got 11.58. We also got 11.58. We do manually. We get the p-values smaller than 0.05. Here they got a p-value equals 0.003. Okay. Of course, they using a computer, they get a much more accurate answers. We are using tables, therefore we get a range of values. Okay. So that's how we know that it is significantly different. Okay. So that is for the Kruskal-Wallis example. This is the equivalent of the Anova. This is the non-parametric equivalent of Anova. And lastly, for the PET test, the non-parametric equivalent is Wicorsen sign rank test. The non-parametric equivalent is the Wicorsen sign rank test. Okay. So, example given here is the blood pressure taken at 2 different times for 36 patients. I wish I have the full table to show to you, But for that, I have to give you the Excel file. But it's only some of the data set. Okay, so you can see this is the table of all the results. Okay, I'm not sure whether you can see everything or not. But I got a feeling the top bar is covering everything. Okay, let's see whether I can move it. Okay, so you arrange the differences. You have a differences of positive and differences that are negative. So this is the differences. Differences is the second value minus the first value. The differences is the after minus before. So you get after minus before. These are the negative values. These are the positive values. These are the no difference. So what happen? You give them the rank based on the absolute value. What is the meaning of absolute value? You remove the positive and negative. You give the rank based on the absolute value. Doctor, how do you get 4 for this value of 1? So you can see how many value of 1 you got. You got 1, 2, 3, 4, 5, 6, 7. Yeah, I repeat back. There are 7, 1. 1, 2, 3, 4, 5, 6, 7. So 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 is 28. 28 divided by 7 is 4. So that's why everybody got a rank of 4. Okay, everybody got a rank of 4. Then you put all the values of 1 to have a rank of 4. Same applies for 2. 2, you got, there's how many 2 are there? There are 3. They are covering the value of 8, 9, 10. So 8, 9, 10. So 8 plus 9 plus 10 is 27. 27 divided by 3. Then you end up a value of 9. So that's why they have a rank of 9 for the number 2 and so forth. So what happens now? What is important? After you give all the ranks, you will sum up all the ranks. Okay? So non-parametric is summing up of all the ranks. So very easy to remember. So non-parametric test, you just sum up the ranks. You look at the smaller value. So here the smaller value is 152. Smaller value is 152. Okay. Okay. Next. Lucky I got this thermos. Why? Because the caterer bagi air dalam beg plastik. So I brought my thermos every day so that I can pour the water from the plastic into the bottle. Okay. So now we have the value of 152. So the value of 152, you look at the table. So which table to look at? We got 36 data set. Out of 36 data set, 3 of them are difference of 0. So now you only look at the critical value of 33. Why 33? 36 minus 3. Okay. So if you look at the next table, for degree of freedom, so sorry, for n of 33 and p-value of 0.05, the critical value is 171. The critical value is 171. Our value is 152. So 152 is between 171 and 151. So which means the p-value is somewhere between 0.02 and 0.05. Okay, therefore p-value is smaller than 0.05. Therefore, therefore the null hypothesis is rejected. There is a significant difference of the blood pressure measured at 2 different times. BP before resting is significantly higher. then after resting. Okay, so you want to check your BP, always rest first for 5 minutes or 10 minutes before checking the BP. Otherwise, you end up getting it higher. And make sure the nurse that measuring your BP is not too pretty. Otherwise, the BP goes up for a different reason. Alright, so and that is the concept of Wicorsen sign rank test. Is there a test for that inside Spss? Yes. Click Analyze, select Non-Parametric, select two related data. So when you select two related data, you end up with this test, which is the Wicorsen sign rank test. As you can see, they give you the positive ranks and negative rank, which is the same like what you got, which is 152 and 409. And they give you a p-value of 0.021. Okay, you remember back the one we got 152, 151 is for 0.02. So ours is 152, therefore it is 0.021. So it means there is a significant difference of the blood pressure before and after resting. Okay, next is the Spearman Correlation. I will just go through. Remember, as I said before, everything can be done through Spss. Okay, Spearman and candle rank is for non-parametric data. Okay, non-parametric data. Also for non-linear, you can use Spearman and candle rank correlation. Okay, this one story about Spearman. Okay, so what the value you get from Spearman, it is the row. Okay, it is the row. Okay, example given here is based on visual acuity. Okay, which is an ordinal data set. And you can see how we calculate the if we are doing for calculation here given is for glucose level and BP, and we can see the formula there, and it is complicated because they're getting the difference of the rank. It is the difference of the rank, then they square it, then they end up summing up the square the square of the differences to put inside the formula, and then you get the row value, and the row value is converted to become the p-value. So in short, not for you to do manually, but for you to do using Spss. Spss will do it for you automatically. Okay, no need to calculate manually. Okay, otherwise you have to look for the Spearman table and convert the value of the row against the p-value. And for you to become significant, your row value should be very large indeed. Okay, kena 0.5, 0.6 before it becomes significant. Okay, so what happens if you do it using Spss? You get a result like this. So they just tell you the p-value is 0.097. Sorry, the p-value is 0.599. The row correlation is 0.097. Okay, my apologies. Okay, my mind started wandering off. So just take note. This one is the row. This one is the p-value. Okay, so that is Spearman correlation. Again, inside Spss, you just click and you get the answer. So just take note, for non-parametric analysis, you have to use the median and quartiles. For non-parametric analysis, you should not use the mean and SD. You use the median and quartiles. If the sample is very small, maybe instead of giving the median and the quartiles, maybe you can just give the range of the values. Alright, so otherwise, you just giving the p-value, very hard to make sense. Tak tahu yang mana lagi tinggi, tak tahu yang mana lagi rendah. You do not know which group end up with a larger value. Doctor, which one to use? Personally, on my part, I prefer parametric. If your all the assumptions are met, then you use parametric methods. Why? At least you can do estimation, you can do confidence interval. And the more important part, if you are doing parametric method, you can do multivariate. You can do multivariate. You can do multiple linear regression. You can do multiple logistic regression. You can do GLM. You can do repeated measures. If you are doing non-parametric, non-parametric tak boleh. Saya ulang balik, non-parametric tak boleh proceed to multivariate analysis. Okay? I hope that's clear. Why? Because it is clearly stated under the non-parametric analysis. Sorry, it is clearly stated under the multivariate analysis, the data must be normally distributed. If you cannot do parametric analysis because the data is not normally distributed and you can only do non-parametric, therefore, automatically you are disqualified from using multiple linear regression or any of the multivariate analysis. And with that, oops, okay. Next one. Which one to use? Tak sure, buat duduk. If they are the same, then you can use the parametric one. If they are different, use the non-parametric. Okay? And with that, thank you very much.
Okay, thank you very much, Prof. So we will proceed with the Q&A session. We do have 3 questions. The first question is, what if we measure using
I have to mute my mic. Sorry, my apologies. I keep forgetting that. Then I cannot see my mic. Okay, up there. Okay, I'll start sharing. Okay, you can read again.
Okay, so the first question is, what if we measure using the wrong test?
Okay. Okay, if we are measuring using the wrong test, then you end up with the wrong answers. Okay, but the thing is right now, it will come back to your supervisor. Okay, so since your supervisor has got his master's or his PhD already, so your supervisor should be able to identify that and put you on the correct path. If your supervisor is the type that don't want to answer your question, he keep answering, go back and read up. Go back and read up. So if you read up, you still don't know the answers. I have already given to you just now the last time. You should contact the statistician. The link I gave you earlier, ppukm.setmore.com. Okay, I'm just going to click on the button again. I'm going to type the answer. Okay, I tak boleh klik. Okay, I tak boleh klik, sorry. Okay, so ppukm.setmore.com. ppukm.setmore.com.
Okay, so the next question is, what if Kruskal-Wallis test shows significant statistical analysis? Is it necessary to proceed with Bonferroni procedure?
Okay, you have to understand Kruskal-Wallis is non-parametric. So when non-parametric, they don't have the Bonferroni. Bonferroni is under Anova. Okay, so it is under Anova for the parametric one. So if you Kruskal-Wallis shows significant and you want to know which group is the significant one, then you proceed with Wicorsen rank sum test. Okay, you proceed with Wicorsen rank sum test. So I'm just going to type there Wicorsen rank sum test. Okay, not Bonferroni. Bonferroni is for the parametric version.
Thank you, Prof. So the next question is, for the Wicorsen rank sign test using blood pressure parameters, for example, would it be more appropriate to use paired test since PP is usually parametric?
Okay. Sekejap. Tak tahu. Tengah cari cursor. Cursor tak ada. Okay. If you look carefully now, okay, just now the example given was based on a very small sample size. Okay. And for that example, we already did the KS test, the Kolmogorov-Smirnov test. And the data was not normally distributed. That's why we proceed with non-parametric test. Okay, I did not demonstrate that one just now because for the lack of time, but in my normal class, we do the KS test first. We do the KS test. After we do the KS test, we prove that the data is not normal. Therefore, we proceed with the non-parametric test. So this one, it is because we cannot use the PET test because the data was not normal. Okay.
Okay, thank you. Our next question is, can we do a meaningful discussion of our study if after all the tests, our p-value is, let's say, 0.059? Thank you.
Okay. Yeah. Okay. Okay. We tend to get this kind of scenario when the p-value was almost significant. Tend to happen when we got a very small sample size. Okay. So basically, how we can get this thing done to get a good p-value of 0.05 or less. Sometimes it is a simple matter of just extending your study a bit longer and increasing the sample size. Okay, then your p-value becomes significant because it's so little, 0.059. If your data was done using parametric analysis, you can check whether the 0.059 could be smaller by doing multivariate analysis. Okay, I repeat, this is only valid if the data is normally distributed. So you can proceed with multivariate analysis, and then the multivariate analysis, after controlling for confounders, maybe your p-value become better or maybe it will become worse. Okay, so that is how we should proceed if your p-value is borderline. If your p-value is borderline, either you increase the sample by extending the study or by doing multivariate analysis. Okay.
Okay, so thank you, Prof. So I think now we should proceed with our last lecture entitled Agreement Analysis and Kappa. Thank you.
Okay, thank you very much, Mr. Chairperson. Okay, this last part, I know I'm going to lose most of you because, okay, first and foremost, just to make everybody become comfortable, just take note this agreement analysis is put in because of request from pathology department and radiology department. All the other department are not going to use this at all, so you can go and look for your lunch because you are not going to use this. This one is only for radiological department and pathology department. That is the only reason why this lecture is put in. Okay. So this is something that you don't have to worry about. Okay. The last time this is one of the topics that I like to tai chi to someone else. You know what it means tai chi, and just the word come pass to someone else. I don't like to do this topic because it is quite difficult to explain. It is quite difficult to explain, and especially in this group of clinical students, clinical postgrad students. It is easier to explain for the epidemiology class because they already have all the grounding lecture or all the foundation related to this. Okay, so it is not an easy topic to cover for you all. But I will do my best. I will do my best. And I will start by changing my background first from my Gambar ASK. I know kejap lagi kan Khairi akan bising. Dr. Azmi kenapa tak tukar background? Ada kejap. Okay, I was supposed to use the other background. The other background is at the bottom. This background. Sorry. Somehow this one does not look so well. Because what happened, the green screen, this area down here is not well lighted. By right, we should be using external lights. So that's why it looks horrible. Suddenly my hand got apa macam berantu glowing green at the side. Okay, so let's get the PowerPoint up. Okay, this is the end of the torture for you all. Also the end of the torture for myself. Okay. The pain is going to end soon, so just bear with me. Kesakitan akan berakhir kejap lagi, jadi mohon bersabar. Okay, I'm going to share the screen now. Share screen 2. I saw the video, so I know there's not much difference. When I click share, gambar macam sama je. But except for the difference at the top right side, there'll be a small video of myself. Okay, but at least this way I get a bigger picture of me. I'm big, 107 kilogram, but here on the Zoom I'm bigger. Okay, maybe I should take a photo of this, me being a big size. Okay, something to share on my FB today. Me being big size on the computer and screen. Alright. Okay. So just take note, okay. This thing is something that will never be done for most of you all, because most of you are going to do clinical trial or maybe cross-sectional, sometimes just case control study. Currently, the only group that is doing cohort study is the pure Center for Prospective Urban Rural Epidemiology Study, and the Malaysian cohort group. Okay, those are the only cohort study. That's why I was surprised that day when we did the survey, a large portion of you answered cohort study. Okay, I do not know where we have gone wrong during the lectures. So this part of the lecture is specific only for this group. For those doing diagnostic testing like radiology department and pathology department. Okay, so inside this agreement analysis, we are going to cover about by right lah, we're supposed to cover about sensitivity, specificity, and receiver operator curve. But since my topic is only for kappa and agreement study, I'm just going to cover that. Okay. So usually for the people from Petho and radiology department, whenever they come to see me asking about this, I tend to just give them a set of articles for them to go through and for them to correct their proposal accordingly. Okay. Still got 102 participants, okay lah. I thought most of you will have left already. Sebab Petho dengan radiology, I think there's about 20 of you only. Okay, let's look at the clinical agreement and reliability analysis. Okay, so usually you have a test, your X-ray, your CT scan, your echocardiogram. According to my echocardiogram, it says my ejection fraction is 0.6. I can't remember exactly, something like that. So all these tests helps in the doctor in managing their cases. Okay, so whenever you look at the test, the results, we look at the validity of the test. How good is the test to identify the sick and healthy individual? Right now, the most contentious results of the test is the PCR for COVID. Masing-masing bila kata positif COVID, semua kata, betul ke test tu? Boleh percaya ke result tu? Aku rasa okey je. Yalah, of course, 90% of us who are infected by COVID, do not have any symptoms at all. They are quite happy, asymptomatic. Only about 10% are suffering badly from the infection. Okay. So, reliability, how stable is the result of the test. If you do the PCR now, then you repeat again, mula-mula positif, negatif, then positif. What? So, susah lah kan? So that day there was argument. PPUKM do the test for PCR, got positive. Hantar dekat KKM kata negatif. Lepas tu patient discharge. Lepas tu things look very bad for us. Okay? So how stable is the result of the test? Is it repeatable? Is it the same? And of course, efficiency and cost effectiveness. Kalau jangan marah, aku bagi contoh tu. Okay. So how to measure? Okay, how to measure. So we are going to discuss about this one already covered partly by Prof. Isenaina about accuracy. Okay. He also covered about reliability. So I'm just going to cover only on the test. Okay. So how to measure accuracy? That one we do sensitivity and specificity. Okay. This one not covered by any of the speakers during this talk. Somehow it was thought not to be required, not to be important. So instead, we're going to talk about agreement analysis. So agreement analysis in the sense that we will look at reliability. So if the thing is for qualitative analysis, we're going to look at kappa statistic and AC1 statistic. If it is for quantitative data, we're going to look at the blunt element plot and the Cronbach alpha coefficient. Okay, so I know Isenaina covered at length about reliability. I know he has covered a lot of things about saying that if it is not reliable, it is not valid, so on and so forth. I'm not going to cover that part since it has been well covered by Isenaina. Okay, I'm just looking at the statistical test part. Saya hanya melihat pada ujian statistik. Okay, so okay. Already got question. Must be very good topic to have suddenly got question already. So early. Okay. So there are things that we look at the reliability of the test. If there is only one observer, if I look at something, the same thing again and again, do I see the same thing or different? Or between I and Fitri, we are two different persons. We look at one result. Do we have the same interpretation or is it going to be different? So intra-observer, myself, I see the same thing again and again. Do I come up with the same conclusion? Or inter-observer, when you have more than one observer, do you have end up with the same observation? Example is interview student masuk medik. You got two interviewer. Okay. So one interviewer say, oh, this is a good student. I want him to enter medical school. The other one say, no, useless one lah. We don't want this kind of people. Okay, we got the inter-observer variation. Then the other one is repeatability or reproducibility. How stable is the results if it is repeated many times in similar condition and situation? Okay, so how do we measure reliability? So as mentioned just now, we got kappa analysis, we got AC1 statistic, we got blunt element plot, Cronbach alpha coefficient, intra-class correlation. Okay, these are advanced topics because the only thing that usually taught is only kepa lagi. Macam nak kepak ayam lagi. The only thing that we always taught is just kappa analysis. Okay, the rest were rarely taught. But since I'm teaching advanced statistics class, we cover all these topics on a regular basis. Okay. But in the normal classroom, it is the only thing that is usually covered is just kappa analysis. Okay, let's do a kappa analysis. Okay, here's an example where we have examination of the same 100 fundus photographs by one clinician. Okay, okay, there's going to be a problem here. I know you cannot see the top part because for me it is also covered by the control bar. The last time I play around with this, I end up losing everything. Let's see whether I can cannot bring out. Sorry. Okay lah, mampu dia lah. So agreement between two exemptions of the same 100 photograph by one clinician. Okay, one person. I look at the 100 pictures. First round, I give my result. Then I do again, the same thing. I do again. Even I cannot agree with myself. You see? Even I cannot agree with myself. Kat mana tak agree? You can see here. First round, I say moderate. Second round, I say little retinopathy. Okay. First round, I say this one got little or no retinopathy. Second round, I say got moderate. Okay. Doctor, is this same like Manova? Yes, it is similar like Manova. Table similar like Manova, but here we are not interested in Manova. We are interested in measuring the agreement. Okay, same table but different analysis. Oops. Rasa baru makan nasi lemak, dia lapar balik lah. Must be lunchtime already. My wife said, I'm always hungry because maybe I'm diabetic. I hope not lah. Right now, nowadays we daily checking my blood glucose level. So because of that, now daily I have to cycle. Okay, so now we got another scenario. So another scenario, we got two different person. Okay, first clinician Azmi, second clinician Fitri. We look at the same 100 photograph. Lagi tak agree. The more the disagreement. Okay, so moderate or severe retinopathy. I say moderate or severe retinopathy. Fitri say little or no retinopathy. I say little or no retinopathy. Fitri say moderate or severe retinopathy. So there were out of 22 out of 100 that we did not agree upon. So when we see like this in a scenario, then we do the kappa analysis. We see the level of agreement. So you can see here, okay, this is, first we look at the observed agreement. So I and Fitri only agree 78% of the time. Okay, why 78%? We got this one 46 we agree upon, and here's 32 that we agree upon. So 78% we agree. So look at that one is observed agreement. Then of course we have to see what is the expected agreement. So expected agreement, okay, this is where the trouble comes. Okay, how do we calculate expected agreement? Okay, don't worry, that one is in the next slide. Okay, so what is the expected agreement for all the portion? And please take note, okay, this one all comes up to 100. Okay, okay, you have angguk, geleng. So observe mild severe. Okay, so you have again the angguk, geleng. So 58 times 56 divided by 100. Then you have the next one, 44 times 58 divided by 100 and so forth. So that's how you get these values. Same like chi-square. So that is how you get the expected agreement. So the expected agreement, based on that, angguk, geleng, is supposed to be 32.5 plus 18.5. So you end up with 51%. So, but therefore, they expect the agreement level between I and Fitri is supposed to be 51%. But now we got 78%, which is good already. Which is better. So this is observed agreement O, this is expected agreement C, and this is actual agreement beyond chance. Okay, so therefore, based on that, you put into the formula actual agreement beyond chance, which is 78% minus 51, divide by potential agreement beyond chance. So potential agreement beyond chance is 100 minus 51. So 100 minus 51 is 49. So therefore you get a kappa of 0.551. Sorry. That's guess. So we have this table of kappa values. So just now, as you can see, agreement between me and Fitri is 0.551. Okay. So 0.551, it is here, moderate agreement. So I and Fitri were in moderate agreement with one another. Okay. All right. Okay. So sometimes, okay, they don't use the other table, this one. Okay, Dr. Azmi, where can get this table? Dekat Wikipedia je. Dekat Wikipedia. You look under, there's two kind of agreement. There's flash kappa and coherence kappa. You can check them both. Some of them use this one. Some use the agreement analysis using R method, which is not that common. Okay, this is much more common. Okay, can we do it in SPSS? Yes. Okay. Don't tell me, are you paid for by SPSS? No. But I was responsible for bringing SPSS into UK Medic way back in 1997. But of course, we started using the illegal version rather than the legal version. Then we found out that UCAM already have the legal version, so we started using the legal one. Can you all get the legal version? Cannot. Sorry. Okay. So under SPSS, just click on kappa and they will give you the answer. Okay, here when I do the same analysis using kappa, just now we did the manual agreement, the value was 0.551. So when we did the p-value is very significant. Okay, but of course I already told you earlier, for kappa we don't care about the p-value. We look at the value of the kappa, we interpret based on the value of the kappa. Okay. Sometimes kappa cannot be used. Why kappa cannot be used? When the outcome is very small. When the outcome is very small. Okay. When one of the category in agreement is low, the kappa value is artificially low despite the high agreement value. For example, the one given in the table here, okay, you have the agreement for one part very high, no disease 85. The one with the disease very small, 5. Okay, so you can see agreement level here is 90%. Observed agreement is 90%, but because of the small value, okay, you cannot use kappa, because when you use kappa, you end up with agreement level of only 0.444. So instead, what you should do AC1 statistic. You should do AC1 statistic. Sorry. Okay. Basically, my battery is running out already. I'm looking at the wrong thing. I'm clicking on the wrong thing. So this is a formula for AC1 statistic. Okay, I need to move. Yeah. That's a formula for AC1 statistic. The camera is auto tracking. So very sorry. Okay, I'm going to hide myself. Okay, let's hide me. Jom kita sorok diri kita. Studio mode. I'm going to hide myself. Okay. So you can see the formula. Okay, AC1 statistic equals to this value divided by this value. And this value P is A plus D divided by N. So A plus D divided by N. Okay. Then this one is this value. Okay. But for the Q, you have to get the A1 and B1. This is the A1, this is the B1, this is the 2N. So you have to calculate this manually. Why you have to calculate this manually? SPSS tak ada. SPSS tak ada. So here, you can see instead of getting a kappa of only 0.444, you end up with AC1 statistic of 0.878. Okay, this is more consistent with the two raters having the same rating of 90% of the subjects. Alright? Okay, so, and that is the explanation. Okay, right now I'm looking for my cursor. My cursor is missing. Okay. Okay, I'm back. Okay, let's go to the next one. That is AC1 statistic. Okay, so we already talked about kappa. So kappa can be used for category data, but if one of the group is very small, one of the outcomes is very small, then you have to use AC1 statistic. So after that, we have to look at quantitative data. Quantitative data, you got three. You got blunt element analysis, we got ICC, we got Cronbach alpha. Okay, let's go and see. Okay, doctor, just now you showed us Psn correlation. Why we cannot use Psn correlation? Can, but you have to understand correlation by right is not a measure of agreement. Correlation is a measure of relationship between two variables. Okay, two different variables, the height and the weight. If we're trying to show agreement, you cannot use correlation. And you also cannot use a PET t-test. Okay, you cannot show a PET t-test. Okay, why? Okay, if you use correlation, both got the same correlation. Both got the same correlation. But the problem now, this one started at a higher point. This one started at 0. Okay. Doktor kacau. Okay, saya try gerak tadi. Nampak? Dia tak dapat kat 1. Dia tak dapat kat kosong. Okay. Dia tak dapat dekat kosong. So that is why you cannot use correlation. You may have the same high correlation, but the one that shows agreement was the one on the right side, not the one on the left side. Okay, so instead of doing a correlation or doing a PET test, you do what we call a blunt element plot. Blunt element plot describes agreement between two quantitative measurements. There is no p-value available to describe this agreement, but it is rather a quality control concept. Okay. In all of my life here in UCAM, the one and only time somebody asked me about this blunt element plot is someone from pathology department. Okay. So what I'm telling you, don't worry, you're not going to use it. Okay. So the difference of the two PET, the PET to measurement is plotted against the mean of the two measurements, and it's recommended 95% of the data points should lie between the plus minus 2 standard deviation of the mean difference. Okay, so it is a matter of plotting. So how I did it? I did that using SPSS, but it requires a lot of calculation and what we call computation and transformation to calculate it. Basically, what happened was, this is an example given here. It's between two different instruments to measure temperature. Remember that temperature, you go to the kedai makan, you kedai makan, ada orang pegang tangan, ada orang letak dahi, ada orang letak mulut, whatever. Okay, so then you have the correct one which you take and put under your tongue. Geli. So people are asking me, Dr. Azmi, what is the most accurate measure of body temperature? I said the most accurate must be from the central body. To measure the central body, you have to put it up your ass. So of course nobody wants to go kedai makan cucuk thermometer kat situ kan. So that's why we have to make do with the thermometer yang gunakan infrared. Okay, so that is the best compromise that we can do for. But if we do the measurement agreement, we find that this infrared one not so accurate. Yeah, the infrared one not as accurate as the one put under the tongue. Okay, you can see here the agreement is the correlation is 0.871. Okay, so 0.8 looks good, very strong. Okay, but when we do the blind element plot, that's when we realize that the dots are everywhere. So you can see here what happened is we use the formula A minus B, and then A plus B divided by 2. Okay, then we look at the differences, and then we look at the average. In fact, the A plus B divided by 2 is the average. So you can see here the temperature at 37 degrees Celsius, our normal body temperature, okay, is everywhere. The difference can be up to 1.5 Celsius, 1.5 degree Celsius. Okay, ada seorang pakcik tu sampai 39 degree Celsius. I think this one memang COVID case kot. Alright, so whatever it is, I'm just trying to show you that this thing could be a problem. Why is it a problem? Okay, because you just show that the high variability between all the two instruments in measuring temperature. Okay, and this large deviation could be either flaw of the instrument. Maybe instead of taking the temperature using the forehead, the person uses his hand to check the temperature, or could be operator error. Okay, because maybe the machine is under the sunlight. Okay, in McDonald dekat Bukit Subang, the night alarm, the thermometer is at the front door, and the front door is under the sun. So you come at around 38, you come around afternoon at 1 o'clock, everybody is going to have temperature above 37. Okay? Alright, so that is the issue here. Just to take note, so blind element plot is a good way of measuring the accuracy or the agreement between the two instruments. So how do we interpret? We look at the 2 standard deviation. How many dots are above and beyond the 2 standard deviation? How many dots are between the 2 standard deviation? Between the 2 standard deviation, we are okay. Acceptable differences. If it is too far away, then somewhere okay, Houston, we are in trouble. Okay, Houston, we have a problem. Okay, so here this one we have a lot of problem. 1, 2, 3, 4, 5. This is our Apollo 11. Oh, sorry, Apollo 13. This is our Apollo 13. They are all very wrong. Okay, these are all. So these are the 8 data set that is beyond the. So is it important? The difference is 1.5 degrees Celsius. So you tengok, kalau 1.5 degrees Celsius can make difference, someone have COVID or don't have COVID, this is how we decide lah. But my wife, that day, she went to the bank. The girl said, oh, my wife's temperature is 28 degrees Celsius. And she did not allow my wife to enter the bank. Bloody hell. Come on lah, 28 degrees Celsius, something wrong with your machine lah. Not something wrong with my wife. Okay, here's the example that I showed on how to do the blind element plot. Okay, basically they just showing we got two machines. We got a Mercury and we got electronic BP set, and we check and we get the mean and we get the difference. Then we plot accordingly. So this is how we do it: get the mean, then we get the difference, then we plot it accordingly. Okay, how we plot? We use a scatter plot, and we got a table looking like this. And this is how we check for agreement using the blunt element plot. Okay, as you can see, the most of the BP are okay, but some of the BP lari gila babi, 25 millimeter hydrogen. Okay, so for your information, I still have the mercury BP. I just realized under the Malaysian law, and we are not supposed to keep the mercury BP set after the year 2008. Sorry, 2018. Now it's 2021, 3 years already. I still have the mercury one. Because the mercury one is accurate. My electrical one, whenever I don't trust the electrical one, I take my mercury one. My wife very unhappy I kept the mercury one. My wife is a biochemist. Alright. So that is the agreement, and we talk about blunt element plot. The other one is by looking at tolerance, okay, between the two machines. So we look at the difference, whether there's acceptable tolerance in terms of the differences between the instruments. That is how another one of looking at the tolerance. Okay, so we covered blind element plot. We covered blind element plot. We covered tolerance. We are going now towards the end already. Okay, we got Chrombar Alpha and ICC. So Chrombar Alpha. Okay, this one, if you are doing questionnaire, you tend to have to do a lot of Chrombar Alpha. Okay, so you got items, you got questions, you do quality of life. You want to see whether your questions got reliability, got internal consistency, you do a Chrombar Alpha coefficient. Okay, it is used to measure internal consistency. The value should be above 0.7. Okay, how do you do it? Inside Spss, just click Analyze, Scale, Reliability Analysis, select the two variables that be compared and move them into the box marked items. Then you select Chrombar Alpha, then you run analysis, and you get the answers. But of course, usually we don't do only for two items. We do for many items at the same time. So your questionnaire quality of life got 36 items. Why 36? Because you call it the short form SF36. So based on the 36 items, you put it inside the Chrombar Alpha. You run the analysis, and then you check for the alpha. Okay, for this example, I showed the data came from the BP measurement from two different sets, a mercury manometer and the electronic BP set. Okay, which is okay. So I'm going to show it to run. So you can see here, we have a Chrombar Alpha of 0.9694. So we are okay. We are okay. So Chrombar Alpha is quite high, very high internal consistency. Okay. So 94% of the points are within plus 2 standard deviation. Yet some of the readings differ up to 25 meter hydrogen. Yet the Chrombar Alpha says there is internal consistency. Okay. So you have to be very careful how you want to interpret this accordingly. Okay. All right. So in short, use of which reliability analysis depends on the type of data being analyzed. Some reliability tests require subjective judgment during interpretation. Okay. Doktor tak sentuh ICC. ICC is GLM. You can check my notes on GLM on the website. Then you can do it yourself. All right. Okay. Thank you.
Okay. Thank you very much, Prof. So we do have two questions. The first is from Dr. Chin. My research is about comparing you among different stages of AKI, which is AKI stage 1, 2, and 3. Kruskal-Wallis shows statistical significance. When I proceed with the Wicorsen rank sum test for the pairwise comparison, do I need to divide the p-value of significant to be 0.05 divided by 6?
Okay. Sorry for the evil laughter. Yeah. Okay, I just repeat back because just now what happened, I was still trying to shut down my screen. And you may have missed the question. Allow me to... Okay, first, let's make Friday happy and put up the background of the medical research week. Okay, I just repeat back the question. Chin Jianwei, my research is about comparing the length of stay in ICU among different stages of AKI. Above ni, okay, acute kidney injury. Okay, thank you. Acute kidney injury, okay. No acute kidney injury. Acute kidney injury stage 1, stage 2, stage 3. Okay. Kruskal-Wallis shows its statistical significance. Okay. Okay. A very good question by Chin Jianwei. Basically, he's asking about the problem of the alpha error. So the alpha error, okay. The alpha error is basically when you do multiple comparison, there's issue of the alpha error, whether it is it should be reduced by dividing by number of comparison. Okay. Okay. I'm a bit hesitant to answer this because the scenario where we divide the comparison is something that we reserve for the Anova method of analysis. I have never done that for the non-parametric one. So I'm not really sure whether it is feasible or possible or should be done or not. Okay. The problem of the length of stay, it is surely will be non-parametric because most of them will stay for a short while. Very few will stay for a long term. That's why you end up with a not normal distribution of the length of stay. Okay, so for me, I will if you have proven that the length of stay is different, I would just do I will just calculate the median and the IQR for each group for the no AKI, AKI stage 1, AKI stage 2, and AKI stage 3, and present as such. Okay, and I leave to the readers to make their own assumption. The difference is where. If you do the Wicorsen rank sum test for pairwise comparison, I will present them separately. Means I present them not as a group, but I present, okay, this one is a comparison between no AKI and stage 3. This is no AKI and stage 2. This is no AKI and stage 1. So I'll present them separately, not together as a single group. If I understand the problem of the p-value and the problem of the alpha error. Okay. Because I'm not sure whether you can divide the p-value for the non-parametric one. I only know it is usually done for the parametric. The adjustment is usually done for the parametric. Okay. I hope that's clear. I cannot answer more because we have never done for non-parametric. Okay. Okay.
Thank you. Next question is, can you explain how to get the expected count? Thank you.
Angguk, geleng-geleng. It's the same like the chi-square. Same like the chi-square. So when you look at the total of the I think I'm going to show you the slide again. Okay, let's see. I'm not going to use the normal way. I'm just going to share directly. Angguk, geleng-geleng. Angguk, geleng-geleng refers to, okay, you look at the sum. You look at sum. 50, you see, okay, I'm going to put my cursor on the mouse. So you can see here 58, 56. So 58 times 56 divided by 100, then you get 32.5. Okay, this one, the 22.5 is 58 times 44 divided by 100. 23.5 is from 42 times 56 divided by 100. 18.5 is 42 times 44 divided by 100. Okay, angguk, geleng-geleng. Okay. Alright. Okay, thank you very much.
Okay, thank you very much, Prof. Azmi. So I think we have no more questions. So we would like to thank for your presence today. So we will meet again tomorrow. So we would like to share the QR code for the feedback form as well as for the MMA. Okay, thank you.
Got one more. Oh, dah. Okay, done. Okay. Kaidi, share QR code. QR code MMA. Aku pun nak attend. Aku pun nak 8 point. Thank you.
Masuk pula bang.
Tahu.
Share cepat.
Aku jujur tu aku dah tahan. Bateri dah habis. Bateri kat sini dah habis. Bukan bateri notebook.
Ingat apa? Ingat dia kena pakai je. Yang ni. Kalau saya buka dia off. Dia punya earphone. Jadi itulah yang tadi ada masalah tu.
You lari pun. Tak, by right is supposed to be 10 feet. You tak sampai 10 feet pun tadi.
Dia kalau kita lepas kepada dia terus off automatic. Prof, jadi saya dah tu lah.
Okay, dah habis.
Last year Prof kata sama overseas, so insyaAllah tahun ni lah Prof.
Okay. Alhamdulillah. Kena stop streaming.